Sí, sí. Ey, ey. Bien, empecemos la presentación. Lo que vamos a hacer en la introducción al evento es mostrar todo lo que ha pasado estos 4 años en que hemos creado el grupo de usuarios, y haremos un pequeño recorrido por las actividades que han pasado este tiempo.
Sí, pues buenos días una vez más. Disculpen el ruido Es un mensaje del más allá que nos quiere decir algo. Bien, pues sí, disculpen, no sé si se puede componer o no, porque está medio molesto, ¿no? Pero bueno, vamos a comenzar. Este es el 4º año, como les decía Plinio. Yo soy Rolando Carrasco y llevamos prácticamente del 2012 a hoy coordinando el grupo de usuarios en México. Existía ya usuarios en años pasados, sin embargo me parece que Oracle no lo había enfocado tanto a tecnología, y por eso es que Plinio y yo retomamos la idea y nos dimos a la tarea de generar pues una serie de eventos, incluyendo que es el Otn Tour, que no únicamente pasa por México, sino que pues prácticamente en todos los países de Latinoamérica hay una parada de este evento. Y bueno, este año, que es nuestro 4º Otn Tour, lo cual además nos tiene muy contentos, reúne a una serie de personalidades, llamémosle así, gente que viene de otros países a darnos pláticas, con el común denominador de que son pláticas totalmente técnicas. ¿Sí? La idea del evento siempre ha sido que sea un contenido técnico y que no sea un evento pues más, digamos, ¿no?, de marketing de Oracle, en donde queramos pues venderles más licencias, que desde luego siempre es importante, pero quizás más importante ahorita sea que el contenido técnico sea de su agrado, ¿no? Y en eso es que nos esforzamos y generamos una agenda para ello. Entonces, pues ahorita vamos a hacer una recapitulación, como bien decía Plinio, de los eventos que hemos realizado, y posteriormente ya nos acompañará Pablo, que pues es la persona que lidera de alguna manera a la comunidad de Latinoamérica de OTN, y después nos dará una charla Team Con. Entonces, Plinio, pues si quieres comenzar.
Bien, en la siguiente lámina, bueno, nosotros empezamos actividades el año 2012. Empezamos primero con un par de eventos locales en Ciudad de México. Cada evento tuvo 40 personas aproximadamente. Hicimos unos 80 participantes ese primer año. Hola, hola, ¿ahora sí? Bien, tuvimos, el primer año tuvimos 2 eventos, el 2012, con 80 participantes. Para el año 2013 organizamos el primer Otn Tour. Tuvimos aproximadamente 250 personas. Es el primer evento que hicimos. Y para el año 2014 hicimos un segundo evento del Otn Tour, que llegamos a las 300 personas, y empezamos a hacer los eventos informales, un Geek and Drink, donde hubo cerveza, pizza, un evento muy informal que nos ayudó a coordinar René, que está acá con nosotros. Y para el año bueno,
digamos, la misión que tiene el grupo de usuarios. También habíamos estado coordinando eventos en línea con una serie de webinars. Eso lo paramos, me parece, hace como 10 meses quizás. Sería bueno retomarlo, y pues eso también es un contenido que está a su disposición. Finalmente la idea es que pues ustedes tengan pues contacto a través del grupo de usuarios con la tecnología de Oracle. Entonces, pues esto es simplemente la recapitulación. Hicimos también un evento en Guadalajara el año pasado, que también fue muy bueno. Eso nos sorprendió, puesto que la audiencia que llegó no únicamente era de Guadalajara, sino era de ciudades que están alrededor de la región. Y pues eso nos hizo ver que podemos coordinar prácticamente más eventos en Guadalajara y probablemente en Monterrey. ¿Quién ha asistido a los Otn Tours en años pasados? Bueno, pues una buena parte de la audiencia ya ha asistido, entonces ya saben más o menos de qué es el evento. Como les digo, siempre buscamos que este contenido sea técnico, ¿no? Y en ese énfasis es que pues les pedimos que nos den esa retroalimentación. Si ven que las pláticas no necesariamente están siendo técnicas, que nos lo hagan saber, porque el espíritu del evento es justamente ese, ¿no? Otra cosa relevante es, allá arriba a la derecha de la lámina aparece la cuenta de Twitter y de Facebook. Vamos a hacer una dinámica, ahorita Plinio les va a explicar cuál es, pero tengan en cuenta tanto la de Twitter como la de Facebook, si no la siguen, síganla, porque a partir de ambas cuentas es que vamos a estar haciendo algunos anuncios y además van a poder participar en una dinámica, ¿no?
Sí, importante destacar el evento en Guadalajara, fue por iniciativa de personas que vivían alrededor de la ciudad, que nos pidieron llevar el evento para allá. Así que entiendo de que hay personas que vienen de ciudades distintas a México, o sea, a Ciudad de México. Si tienen intereses también en llevar el evento a su ciudad, coméntenos para nosotros también apoyarlos en ese sentido. ¿Sí?
Okay. No avanzo. ¿Pueden avanzar la lámina, por favor?
Bien, acá si bien nosotros somos los que presentamos, en realidad hay muchas personas detrás de nosotros ayudándonos. Nos han ayudado estos 4 años. Entonces, es importante reconocer su apoyo todo este tiempo, ¿no? El apoyo de Sandra, ¿no?, que está acá con nosotros, René, que nos apoyó en los Kids and Drinks, está ahí. Adrián, que nos apoya mucho en la logística. Perfecto, gracias Adrián por todo el apoyo. A Uciel, que se fue hasta Guadalajara para organizar el evento allá. Y Arturo, que bueno, ahorita no radica en México, pero ha sido un apoyo imprescindible para que el grupo de usuarios siga creciendo.
Sí, y además si alguien quiere apoyarnos en la coordinación de ya sea este tipo de eventos o eventos en línea, o alguien quiere contribuir con algún contenido, pues es bienvenido, ¿no? Eso sí, nunca lo dejen de hacer. Comuníquense con nosotros a través de las redes sociales, que queremos crecer al equipo. Finalmente,
la idea no es que siempre seamos los mismos coordinando el evento, es un grupo de usuarios, no es que sea una empresa la que esté pues organizando esto, sino somos nosotros mismos los que usamos la tecnología de Oracle quienes contribuyen con el evento. Así que pues el que se anime a contribuirnos, como Adrián, por ejemplo, que desde los primeros eventos siempre se nos acercó y nos dijo, oigan, pues yo les ayudo, y al día de hoy pues ha sido clave, al menos en este evento, para que se pueda realizar, ¿no? Entonces ahí no escatimen en ofrecer pues lo que consideren que puede ser adecuado para la coordinación. Y pues también agradecemos a algunos de nuestros sponsors. Justamente pues el evento evidentemente no se hace solo, Oracle nos apoya sin duda alguna, pero además de Oracle pues hay partners de Oracle mismo que nos ayudan con el evento, ya sea dando pláticas o bien pues efectivamente aportando dinero para que se pueda apartar el lugar, se puedan tener las dinámicas que ustedes van a ver, ¿no? Y esos sponsors son los que están ahorita en pantalla, son ustedes conozcan. Si no, pues pueden tener oportunidad de platicar con ellos, puesto que ofrecen servicios justamente de Oracle, algunos de base de datos, otros de middleware, entre otras cosas, ¿no? Y ellos son pues Soltech, Sol for IT, S&P Solution, Index Pro, Dayset y Certificate, ¿no? Entonces,
sí, quizás acá también mencionar y agradecer a la UM por apoyarnos con las instalaciones, y al maestro Miguel Ángel Vargas Abundis, no sé si estaba acá, y no venido, pero que nos ha apoyado para poder organizar el evento en la universidad.
Ok, bien, pues vamos a ir terminando con esta primera parte. Si me pueden ayudar a avanzar la lámina. Bien, pues esto es parte de lo que vamos a hacer al finalizar el evento, que pues lo queremos hacer al final justamente para animarlos para que se queden pues justamente hasta que terminemos el evento, porque vamos a, en particular Adrián nos ofreció estos diplomados que incluyen los vouchers para que ustedes se puedan certificar en diferentes tecnologías. Entonces, al final del evento se va a hacer una dinámica que ahora Plinio se las...
Dentro de la comunidad vamos filtrando a aquellos que no tienen actividad y no han descargado ni software, ni newsletters, ni nada en el último tiempo. O sea que el número real, fíjense la cantidad que hay aquí en México, es más que importante. Esto está bueno que lo visualicen, porque el día que decidan ustedes participar en la comunidad enviando artículos técnicos o alguna cosa que quieran hacer, es que va a ser publicada en esa página que yo les mostré antes, y ustedes pueden tomar provecho de ese tráfico y que la gente los conozca muy rápidamente, porque es un sitio muy visitado por muchas personas, ¿no? Les voy a contar un poco las novedades que tenemos dentro del programa. Tenemos un community website que es lo que ustedes conocen regularmente como los foros de discusión, ¿sí? Nosotros estamos migrando mucho el contenido técnico y migrándolo a esta nueva plataforma, no solo para que ustedes puedan generar discusiones y lo que normalmente hacían en los foros de discusión, sino también poder tener habilidades y features para realizar otro tipo de cosas, como por ejemplo, si tienen una idea y la quieren compartir con otras personas para que esa idea vaya creciendo y la trabajen entre todos, pueden ver vídeos. Es una plataforma renovada que es más flexible y más fácil de usar y bueno, les va a permitir también recibir alertas por email de los temas que ustedes estuvieron preguntando dentro de la comunidad. Realmente tiene un search mejorado, es muy fácil de usar, les recomiendo que entren porque de a poco todo Otn está yendo hacia ahí. La dirección para entrar es community.oracle.com. ¿Será que...? Ahí va. Nosotros por ahora estamos publicando dentro del community site el micrositio, por ejemplo, de este tour, donde ustedes van a ver lo que pasa en el resto de las ciudades. Pueden comentar ahí qué les va pareciendo el evento, las presentaciones, porque por supuesto es interactivo, esa es la idea de una comunidad, poder tomar lo que ustedes opinan acerca de los temas que están, ¿pueden pasar? Los temas que están viendo aquí en el evento. Otra de las novedades, tenemos el Otn Summit, es un evento 100% virtual, enfocado a los 4 perfiles técnicos que nosotros definimos de usuarios dentro del mundo de las personas que utilizan la tecnología Oracle, que son los desarrolladores Java, los desarrolladores y administradores de sistemas, desarrolladores y administradores de base de datos y los arquitectos. Bueno, este evento dura 4 horas, con 4 tracks, uno para cada perfil técnico, que ustedes pueden asistir desde sus oficinas, desde su escritorio, y también incluso pueden encontrar útil este tema de que dentro de un track encuentran atractiva una charla, pero se pueden pasar a la otra en cualquier momento y cambiar digamos, de presentación, ¿no? Al mismo tiempo, al final, tiene una sala, una sesión de chat donde pueden ustedes intercambiar opiniones con los presentadores. Rolando, tú estuviste en la última edición, ¿no? Bueno, esto está buenísimo también porque, ¿qué pasa? Empiezan a participar aquí, yo creo que hay un 50% de miembros que presentan aquí que son de la comunidad. Si son Oracleaces o también, bueno, Product Manager de Oracle que tienen asuntos técnicos interesantes para compartir con ustedes. Está muy bueno, les recomiendo, la última versión fue en julio y tenemos 2 al año. Así que estén atentos, ahí también tenemos de la última edición de la anterior, hemos hecho una interpretación en idioma local de las presentaciones, también lo pueden acceder a eso en community.oracle.com, en la sección de español. Ahí van a ver las presentaciones ya localizadas y van a poder disfrutarlas, son 8 también. Ahí está, bueno, un poco más del Otn Summit, el tipo de presentaciones que hay. Y algo nuevo que estamos nosotros impulsando desde Oracle es la participación de ustedes como usuarios en sitios de terceros, ¿no? Sitios que no son Oracle, donde ustedes pueden enviar sus reviews, lo que ustedes opinan de la tecnología Oracle o cómo ha sido su experiencia utilizándola. Esto nosotros hemos detectado que son sitios que, digamos, los gerentes de tecnología, las empresas más top de Fortune 100 están mirando y fijándose aquí lo que la gente opina de las tecnologías, no solo de Oracle, sino de otros fabricantes de software del mundo. Entonces, claro, nosotros lo que hacemos es invitarlos a ustedes a que opinen de Oracle aquí para, sobre todo, empezar a entender cómo mejorar el asunto, ¿no? Obviamente esto son sitios de review de tecnología de enterprise entre pares, o sea, ustedes van a ver lo que opinan otras personas como ustedes allá adentro de todas las tecnologías. Bueno, la invitación es a que posteen sus reviews, promuevan sus perfiles profesionales ahí dentro, ¿sí? Bueno, de repente va a haber gente que les va a ver a ustedes opinando y eso es bastante útil también. y que compartan sus apreciaciones. Este es un ejemplo de una persona de Latinoamérica haciendo valoraciones, y nosotros detectamos que hay, digamos, sitios de reviews específicos para cada perfil tecnológico, para cada producto. Por ejemplo, IT Central Station es un sitio donde ustedes van a encontrar reviews principalmente de lo que es tecnología Oracle. En cambio, lo que es aplicaciones, hay otros que se llaman Trust Reviews y C2 Crowd. Ahí van a ver más aplicaciones. O sea, esto el traductor no, lo que ustedes tendrían que hacer es encontrar cuáles de esas comunidades ustedes se sienten más cómodos y enviar sus reviews. Bueno, ahora les voy a contar el programa Oracle Ace, cómo pueden participar. Este gráfico está buenísimo porque deja de forma muy clara cómo hacer el camino para convertirse en un Ace. Básicamente pasan dos cosas. Ustedes son usuarios, ¿sí? Pero quizás al comienzo es un usuario inactivo, solo observando lo que pasa en la comunidad, consumiendo contenido técnico, ¿sí? Lo cual está muy bien, porque les viene genial para sus trabajos, para lo que les toca hacer en el día a día. Ahora bien, el camino para convertirse en un Ace es hacer esto para finalmente terminar siendo un participante y promulgador activo en la comunidad. ¿Cómo es ese camino? Bueno, del otro lado se menciona, primero, digamos, uno es un miembro general dentro de la comunidad de Oracle. ¿Cómo? Porque está registrado en oracle.com, porque se unió a las redes sociales de Oracle, las sigue, consume contenido. Básicamente está involucrado porque lo necesita. Luego uno se convierte en miembro de Otn. ¿Qué quiere decir eso? Se suscribe a los newsletters de Oracle Technology Network, empieza a consumir contenido técnico pero más especializado dentro de la comunidad, porque es generado por miembros de la comunidad. Descarga el software y comienza las discusiones en los foros, esto en community.oracle.com. ¿Sí? Es un miembro de Otn. Luego uno se convierte en un miembro activo. ¿Eso qué quiere decir? Básicamente yo lo grafico con que, bueno, hay como una línea y un momento en la vida donde uno decide cruzar y empezar y activar. ¿Cómo? Bueno, en un grupo de usuarios, por ejemplo, en las reuniones pequeñas que ustedes tengan, fuera de lo que puede ser el Otn Tour, que es un evento grande y tal, es decir, bueno, Rolando, Plinio, René, Sandra, quiero participar, quiero dar una charla. ¿De qué? De tal tema. Porque es algo que me parece que le va a servir a los demás. Bueno, eso es activar y iniciar una carrera como un miembro activo, ¿no? en la comunidad. Eso mismo, que es en el mundo físico, las personas lo pueden hacer en el mundo virtual. ¿Cómo? Digamos, participando en community.oracle.com, decir, bueno, no solo voy a preguntar y preguntar y preguntar, sino que también algún día voy a contestar una pregunta que yo justo sé la respuesta. Bueno, genial. Otra forma sería tomar parte en las conversaciones sociales. Hay preguntas que surgen naturalmente ya directo en las redes sociales y uno las puede contestar ahí. Está activando. Bueno, cuando eso pasa, desde Oracle y en específico Otn, digamos que es la comunidad de usuarios, nosotros empezamos a ver eso, esa actividad que ustedes generan. Y lo que queremos es distinguirlo. Y de alguna forma que ustedes sepan que para nosotros es muy valioso. ¿Qué hizo Otn? Creó el programa de Oracle Ace para destacarlos y distinguirlos dentro de la comunidad. Entonces, cuando eso empieza a suceder consistentemente de parte de ustedes, y la actividad es útil, lo que ustedes hacen es útil dentro de la comunidad, empieza a tener como más renombre. Al mismo tiempo ustedes pueden tener un blog y hacerlo regularmente, ser presentador, autor o miembro dentro del grupo de usuarios, y uno ya tiene un perfil establecido dentro de la comunidad. También escribe artículos para Otn, y de alguna forma todas esas calificaciones hacen que un día ustedes puedan autonominarse como para hacer un Oracle Ace, o que otra persona los nomine. Y digan, esa persona lo está haciendo bien, está ayudando mucho a los demás. Para mí que Otn debería distribuirlo. Se completa el formulario, la forma, y ahora les cuento un poco cómo es que eso sucede. ¿Qué pasa? Hay 3 tiers, 3 niveles dentro de Oracle, lo cual es muy bueno para que ustedes puedan iniciar la carrera rápidamente y no tengan que juntar muchísimas calificaciones para poder convertirse en ACE. Entonces, para eso existe la categoría número 1, que es el Oracle ACE Associate, donde ustedes, teniendo contribuciones a la comunidad en 2 canales, digamos, porque tienen un blog ya hace un tiempo, son presentadores en el grupo de usuarios local, bueno, otra más, son miembros activos dentro del community.oracle.com, pero eso durante un tiempo, eso ya pueden autonominarse o otra persona los puede nominar para hacer un Oracle ACE Associate. Cuando eso mismo es sostenido en el tiempo y se involucran más canales de contribución, uno ya puede ser Oracle ACE y al mismo tiempo un día ser un Oracle ACE Director. O sea, es lo mismo, las contribuciones, pero con más volumen y más tiempo se pueden ir avanzando dentro del programa. A punto tal un día de, bueno, convertirse en un Oracle ACE, donde Oracle ya tiene una relación mucho más cercana con ustedes, les ayuda a que promulguen todavía más activamente lo que ustedes saben, pagándole con viajes y que puedan ir a otros sitios contándole a los usuarios lo que ustedes saben. Al mismo tiempo, bueno, ¿cuáles son los beneficios? Ustedes envían la forma, hay un comité que lo evalúa y dice, bueno, yo creo que lo estás haciendo bien, o en tal caso, me parece que tendrías que hacer más aportes. Eso mismo lo ve el comité con un grupo de gente que son los product managers, para también validar si técnicamente lo que ustedes están escribiendo y poniendo dentro de la comunidad es correcto. No si hablan bien o mal de Oracle, sino si técnicamente es correcto. Bueno, ahí se aprueba y ustedes se pueden convertir en un ACE. Esta es la cantidad de ACES que hay en Latinoamérica, un poco por país, puede ser que falte alguna foto, pero bueno, va creciendo, en 2040 ya son miembros. Pero no te preocupes. La idea un poco es que los conozcan. Yo los invito, por favor, Rolando, René, Sanders y Plinio, se pueden venir, para que en primera persona ellos puedan contarles cómo fue un poco su recorrido dentro del programa y lo entiendan de primera persona. Bueno, yo a Rolando lo conozco hace un montón. Sí, tengo el micrófono, ¿no? Rolando, yo recuerdo que él comenzó en la comunidad teniendo un blog que también lo hacía en conjunto con una persona que no sé si trabajaba en Oracle o algo así. En ese momento era, me acuerdo, un blog muy conocido, la gente lo accedía un montón, pero luego él siguió dentro de la comunidad haciendo más cosas. ¿Cuáles de todas ellas fueron, digamos, la que vos pensás más retorno le trajo a la comunidad y a vos? Yo sé cuál es, pero...
Ya, sí, en efecto lo que dice Pablo es cierto. Yo empecé con mi blog en español, debía haber sido 2007. En 2007 empecé a escribir en oracleradio.blogspot.com, quizás alguno lo haya visto. Actualmente tenemos allí cerca de 150 artículos aproximadamente, y probablemente ese es el aporte que más he sentido que le he dado a la comunidad, porque está en español. Okay. Y pues siento que eso sirve, dado que la gran mayoría del contenido está en inglés.
Sí, seguramente la gente cuando hace búsquedas en Google accede ahí y finalmente encuentra algún contenido que le sirve. Para mí igualmente el aporte más grande que han hecho fue formar un grupo de usuarios aquí. Claramente, mira todo lo que es esto, para mí es increíble, esto no existía, ¿hace cuánto?
Pues yo empecé a trabajar en Oracle en 2002 y alguien me dijo, hay un grupo de usuarios. Y a mí me interesó pues como relacionarme con él, y cuando hacían las reuniones pues había una matrícula muy baja, eran como 10 personas. Okay. Y pues ya ahora somos, yo creo que si contabilizamos los de Facebook, habrá unos 1000, Plinio, por ahí.
1000 usuarios, bueno, la verdad es que lo están haciendo bien, es una, para mí, de las cosas más interesantes que han hablado aquí. A René también lo conozco hace bastante. René, cuéntanos un poco cuál fue tu inicio dentro de la comunidad y cómo estás a día de hoy con tus aportes.
Bueno, mi inicio fue muy similar al de Rolando. Tenía mucho la inquietud o no tanto la inquietud, sino más bien encontraba mucha información en inglés, sabía que había mucha gente que batallaba con esto, entonces opté por hacer o iniciar un blog que se llama oracleenespañol.blogspot.com, que se evolucionó a mi propia página. Ahorita creo que tiene cerca también como 120 entradas más o menos. Y pues de ahí ha evolucionado. Actualmente no nada más es el blog, sino también dar conferencias tanto aquí en México, apoyar al grupo de Oramex en estos eventos un poquito más informales, en lo que comentaba Plinio, en los webinars, pero también apoyar no nada más a la comunidad en México, sino también llevar la voz de México hacia otros países, Latinoamérica, Brasil, Colombia. Acabamos de estar en Londres, también en el Oracle Open World. Entonces, ha evolucionado en todo esto, ¿no?
Great.
Bueno, gracias. Sí, es verdad que lo que él comenta es interesante porque llevar lo que uno ya aprendió también en su país a otros lugares para que otros usuarios también lo aprendan es genial. Bueno, y Sandra es especialista en SEO. Ella hace no mucho tiempo se convirtió en Oracle y quisiéramos que nos cuentes un poco también cuáles son los aportes que está realizando en la comunidad.
Hola, gracias. Sí, bueno, yo comencé también con un blog. Desde hace muchos años que empecé a trabajar en esto de sistemas, siempre buscaba información y era consumidora de la tecnología, de los blogs, y siempre pensé, bueno, quizás algún día pueda regresar ese favor, por decirlo así, a la comunidad, y si sé lo suficiente puedo aportar, claro que sí. Entonces, como un pequeño agradecimiento a estas personas que se tomaron su tiempo en ese momento para aportar algo hacia los demás, y ahora me toca también a mí hacerlo de vuelta para que el resto de la gente pueda de alguna manera usarlo y también contribuir con lo que sepan, ¿no?
Está bueno lo que decís porque el espíritu de una comunidad es el bien común. Y en un punto lo que vos estás haciendo es aquello que te dio provecho y pudiste sacar un beneficio, lo devolvés a la comunidad. Está bueno entender de que uno lo hace pero no espera nada y que bueno, el programa ACE aparece distinguiéndolo cuando uno menos lo espera. Cuando menos esperan las cosas suceden. Bueno, y Plinio, Plinio es un live director hace muchos años. Él, no recuerdo lo primero que hiciste, pero sí que es un miembro que viene haciendo cosas desde hace un montón. Lo he visto en miles de eventos, haciendo un montón de cosas. Cuéntanos un poco tu inicio y lo último que estás haciendo.
Mi nombre es Plinio, soy peruano. Yo empecé haciendo una página con un argentino llamado JDeveloper LA, que era una página que promovía el uso de la herramienta JDeveloper y ADF.
Claro, que eso es algo que está bueno, porque cuando uno a veces no encuentra la energía personal para hacer algo, finalmente se puede juntar con alguien más y hacerlo, que también es interesante.
Sí. Y luego, bueno, empecé mi blog personal, que es plinioapp.blogspot.com, donde publico tutoriales de ADF. Y bueno, en el 2010 me moví a México y bueno, acá apoyando a la comunidad, organizando los grupos de usuarios.
Genial. Muchas gracias, Plinio. Muchas gracias a los cuatro. Espero que puedan seguir su carrera dentro de LACE. Ya falta poquito para que algunos de ustedes cambien de categoría, lo sé, porque son activos y la verdad es que para nosotros es fantástico. Muchas gracias. Bueno, con esto termino, porque básicamente esto es como ustedes pueden sacar provecho también de los miembros que ya son ACES, interactúen con ellos. Al mismo tiempo aquí hay Oracle ACES de otras partes del mundo que van a estar el día de hoy presentando. Aprovechen, interactúen con ellos, la calidad técnica de lo que ofrecen es fantástica. Muchas gracias por el espacio, a los miembros del grupo de usuario aquí en México y les deseo lo mejor y mucha suerte el día de hoy. Gracias.
Gracias a ti, Pablo. Bien, pues vamos a continuar. Ahora va a estar Tim dándoles una plática. Esta va a ser en inglés y pues voy a moverme en inglés para darle unas palabras a Tim. Thank you, Tim, for coming here to Mexico. We're very happy to have you here, and we really appreciate your effort to come to Mexico. I know it is a very long trip from your homeland, so thank you and enjoy the event.
Okay. Can you hear me? Yes, okay. So, my name's Tim. I come from the UK. I've been working with Oracle technology for 21 years. I've been doing a website for the last 16 years, and for the last 10 years I've been part of the Oracle ACE program. So that's enough about me. If you've been searching for stuff on the internet and you've come across this website, this is my website that I've been doing for 16 years. It's just something I do for fun in my spare time, and it's why I got invited onto the ACE program. And because of the ACE program, I've got to go around the world speaking about Oracle technology, which is really cool. Can I just ask quickly, how many people in the room are DBAs? Okay. How many people do SQL and PLSQL development? Okay, a lot. Cool. So, the specific thing I want to talk to you about today is an issue about when we call PLSQL from SQL statements. Sometimes we're forced to call PLSQL from SQL. Now, we should always try and avoid this because there's a very specific problem in doing this, which is an SQL statement, it runs in Oracle as a read consistent statement. What happens is, at the point where we issue the statement, Oracle fixes the point in time. If any changes happen to the data blocks, Oracle rewinds those using undo segments to make sure our data looks consistent for the point where we issued the query. Okay, that's the normal running of Oracle. In the same way, if we have a function that calls an SQL statement within it, the SQL statement in the function is read consistent for the point in time it runs. Now hopefully you can start to see a problem. I have a query at this time, read consistent to that point. That query internally calls functions many times, and in those functions, if they reference SQL, then they're all working at a different point in time as far as read consistency is concerned. So as soon as we call functions from within SQL, we potentially have a problem. Should we worry about that problem? Most of the time, no. But sometimes it can be an issue. So if at all possible, we need to not call PLSQL functions from SQL. But sometimes we have to. I work at a university in the UK. When I arrived there, they had some reports that literally never finished. Why? Because they were calling functions, and those functions took a long time to process. In some cases, the select list had 6 functions, and in those functions, each of them took about 3 seconds to complete, and that was happening for every row coming back from the database. So it's many, many minutes, and they never saw the reports complete. I was asked to look at them, and I got them down to less than a minute typically, using some of the stuff I'm going to talk about today. Now, I've got a very short time, so I'm going to miss some demos out. And if some demos go wrong, it's because I was changing them to fit on the screen before we started. So if I hide behind this and cry, that's why, okay? So by default, a function will run for each row coming back from the query if it's in the select list. And that can be a problem, especially if we have the function being called with the same input parameters. It represents wasted work. So what would be nice is if we had a way to reduce the amount of times the function was called. Unfortunately, Oracle gives us several ways. I'm going to show you a little demo to explain the problem. Hopefully you'll be able to see this. I create a little table, very simple. Then I populate it with 9 rows made up of the values 1 and 2, and then a single row with the value 3. So my data at the end of this looks something like this. If I can scroll a little. I have 10 rows, but only 3 distinct values. When I call when I call a function for this data, what's going to happen is it's going to run the function 10 times, but I've only got 3 distinct values, so I only really need it to call it 3 times. So let's see the problem. I'll create a function, and I'll imagine this function does lots of work and takes 1 second to complete, but I'm going to cheat, so I'm just going to sleep for 1 second to represent that heavy workload. I pass in the ID value, I do nothing with it except pass it out. So this is a silly function, but it represents a 1 second wait. I'm now going to run this SQL statement, select function, passing in the ID from my test table, and we'll see what happens. Now I've got to waste 10 seconds because I know what's going to happen, so I'll do a little dance just to keep you entertained. I won't really. You don't want to see me dance. So I get my rows back, 10 rows, 3 distinct values, but it takes 10 seconds to complete. So if that were lots of work happening, this is a terrible situation. So what can we do about this? I'll give you some examples of what we can do. The first thing I'm going to suggest is scalar subquery caching. This has been around for a long time. This has been available since 8i, I believe. How many people are on 12c database? How many people are on 11g? How many people are on something older than 11g, like 10g or 9i? How many people don't know what Oracle is? Yeah? Okay. He's an Oracle ace and he doesn't know what Oracle is. What's that all about? Okay. So what I'm going to do now is, rather than call the slow function, I'm going to rewrite that as a scalar subquery. The first time I saw this, I thought the person doing it was an idiot, because this looks more complicated, and more complicated is bad, yeah? But then they turned to me and sort of went, this is good. So what I'm doing is turning my function call into a scalar subquery. A scalar subquery returns a single row of a single object. That could be a column, a literal, or it could be a complex object, like an XML type, but it can only be a single row of a single object. And with a scalar subquery, we can put this anywhere we can have an expression in an SQL statement. What happens then is Oracle does something clever. It builds a hash table in memory, and for every scalar subquery that happens, it takes the value that's returned and puts it in the hash table, and so it doesn't have to rerun the query. So if it sees this again, with the same ID value being passed in, it won't necessarily run it again. Now the hash table is very small. We can't cache everything, but if we're in a situation where the total number of distinct values is less than the total number of rows, this can be really good. The cache only lasts for the lifetime of the query, so if we run the same query again, we have to do the caching all over again. And I'll show you an example of that now. So what I'm going to do is I'm going to select, using that scalar subquery, and now if we do the timing on that, what we should see is 3 seconds. Why? Because, and we do, because it's only called the function 3 times, once for each distinct value. So I've saved lots and lots of time by not constantly running it when I don't need to. But notice what happens if I run it again. It still takes 3 seconds. Why? Because the query, the cache for the hash table was thrown away and it had to happen again. So there's no benefit in multiple runs. It's the same every time. But it saved me 7 seconds, which is good. I had bad breakfast, I'm sorry. Now in that situation, I was able to change the SQL statement because I changed it from a simple SQL statement to a scalar subquery. That's not always possible. Sometimes the SQL is fixed, but we can change the function. So now I'm going to talk about the deterministic hint. This was introduced in Oracle 8 to allow function-based indexes, but it didn't give us any advantage in this context then. What we can do in 10G onwards is we can use it to give us some performance benefit when we're calling functions. What's going to happen now is that Oracle will see that this is a deterministic function and think, oh, I can do something clever with this. But the thing that's a little confusing is it's all based about the fetch size, the array size, individual calls. So if I have a very big array size, pulling back lots of rows, I can get a lot of benefit from this. If I have a very small array size, it's not so obvious, and that can be confusing. I'm so going to fall down these stairs in a minute. Once again, remember, the cache only lasts the lifetime of the call, not the whole SQL statement, the individual call. It's happening again. I think it's that. So I can hear you now. I best not move. So what I'm going to do now is recreate the function, same silly function, but notice I've put the word deterministic in there. That's a hint. It tells Oracle that I think this is deterministic. Now I'm going to run the original query again. So this isn't rewritten as a scalar subquery, it's just a basic query with the function call in it. And notice how long this takes. It's going to take 4 seconds. So I get my 10 rows, 3 distinct values, and it's taken 4 seconds. Typically, with the deterministic hint, you get the number of distinct values in the call plus 1. Look what I did here. Array size 15 with 10 rows coming back. So it was a single call to the database. What happens if I make that array size smaller? Here, I'm making the array size 2, and look what happens when it runs. There's no repetition in the first call, so I get no benefit. None in the second, I get no benefit. None in the third, etc. It's taken 10 seconds. That's very confusing when you run a select in SQL Plus with an array size of 10, and then a select in another tool with an array size of, say, 1, and a select in your application server with a different array size again. The same query will perform at different speeds, and that's really confusing. And it's one of the reasons I don't like the deterministic hint in this context. So, one of the things we got in 11G was some new caching technology. Essentially, we've got a new pool of memory. I should stop moving, shouldn't I? I think I'm making life hard for the people at the back. So, what we do, what we've got is a pool of memory in the SGA that all the sessions can see and they can take advantage of. We have 2 different types of caching, but they're controlled by the same parameters in the same pool. So we set the pool information, the size, and the way we want it to work with the result cache parameters. We can interact with the pool using the DBMS result cache package, and performance is done using the VDollar result cache views. I'm going to miss this next bit out. So we have 2 types of caching. The first one, we can cache a whole result set. So think of it almost like a materialized view. We run a complex query, we get a result set back. If we see that same query again, we don't run it. We just use the results that are in the result cache. I'll show you an example of that. So I recreate that function, no extra bits in, slow again. And what I do is I run my query, but I put in this hint, result cache. Now this is going to highlight a bug, and we're going to pretend we don't see this, okay? So when I say erase your mind, What we're saying to Oracle is we think the result of this query is worth caching, and it's going to do that for us. It would help if I actually started it, wouldn't it? That's one of the changes I made before I started, so I was expecting that to run. Unfortunately, this is going to highlight a bug in the query result cache, which is it's going to run my function twice, effectively, run the query twice. Let's pretend that doesn't happen. But what we'll see is it takes 20 seconds rather than 10, but let's pretend that took 10 seconds. Now look what happens when I run it a second time. Almost instantaneous. Why? Because Oracle never ran the query. It just said, oh, I've seen this before. I'll use the results from the last run from the result cache. So it doesn't run the query, therefore it doesn't call the functions. What's more, what I can do now is reconnect to the database. So I've got a brand new session, and I can run the function again, the query again, and it's fast again. Why? Because the cache is in the SGA and all the sessions can share it. If the same work happens in multiple places, the first person does the hard work and everyone else gets the benefit. What's more, I can actually tell Oracle to do this for me and let it decide what to cache. So I can do this alter session set result cache mode equal false. Now what I can do is run the query without the hint, and it will say, oh yeah, I've seen that, I know what to do. Brilliant. But if I want more control, I can always say, no, I don't want to use the cache. I'll use the no result cache hint, and it will do the long way again. And we'll see this takes 10 seconds. I would suggest you never let Oracle decide what to cache and what not to cache. You're a better judge of that. But if you want to use that functionality, that's great. I don't think it's the right functionality for my problem here, but the second bit of functionality 11G gave us is, and that's the cross-session PLSQL function result cache, which is really easy to say. So you'll probably call it the PLSQL result cache or the function result cache. This is different because rather than caching whole result sets, it just caches the result of a function call. So let's have a look at that. Oops. So I'll recreate the function again, but this time I have the word result cache. This tells Oracle that I think it's worth, whenever this is called, caching the result. So whenever it sees this function called with a specific input parameter, it will cache the result, and if it sees that input parameter come in again, it will use that result. It won't run the function again. What we can see now is we run the original statement again, but it takes 3 seconds. Why? Because it's only called the function 3 times, once for each distinct value. The rest of the time, it used the cache. If I run it again, that was so quick you probably didn't see it, but that changed from 3 seconds to 0 because it hasn't had to run the functions at all. It's still run the whole statement, but none of the function calls because it's used the values from cache. Also, if I reconnect to the database, reconnect, and look at this, it's still fast. Why? Because that memory pool is in the SGA, it's shared between sessions. So 11G caching is really cool. I'm going to miss the next 2 slides out to try and gain us some time because you shouldn't be doing this anyway. They're just 2 techniques that you can use if you're not on 11G. I've got articles on my website about this, so I'll just miss them out. And it's basically writing your own caching layer using collections in PLSQL or context. But let's forget about that for the moment. So I've told you that scalar subquery caching is good. But then I've also shown you the 11G caching, which kind of looks better because it's even faster after the first run and it's shared between sessions.
So you might be asking yourself, do I care about scalar subquery caching anymore because the 11G caching looks better? And the answer is scalar subquery caching is still useful because it does something that the PLSQL function result cache can't. It actually stops the whole statement being run. And as a result of that, we get less context switches. When we switch from SQL to PLSQL and back again, there's a context switch, and that burns CPU. Most of us are probably paying our licensing for Oracle on CPU. So if we're throwing away CPU, we're giving more money to Oracle, and I'm guessing we don't really want to do that. Okay? So scalar subquery caching is still useful. What you should probably do is use both. So here's an example of that. This will scroll off the screen. I'll have to move around a little bit, but you'll get the idea. I'm going to build a new table, very simple, populate it with 100,000 rows, all of the same value though. So every single value in this table is the same. I'm then going to recreate my slow function. Notice it's using the result cache clause, which means that every single time this function's called, it's going to use the result cache. And because every value in the table is the same, it will only ever call that function once in the whole lifetime of my instance. Okay? In my first test, I'm going to loop through a scalar subquery, and I'm going to measure how much CPU time is being used for that. In the second test, I'm going to loop through a regular query, just select function from table. And what we can see is that when I combine the scalar subquery with result caching, I use less CPU. Why? Because it didn't even have to call the function and then notice that it's in the result cache and use the cache value. I removed context switches, which meant I removed CPU usage, even though both are using the normal result cache. Similarly, in a where clause, I can use a scalar subquery in a where clause, or compare that to just doing column equals function call. And once again, when I use the scalar subquery and the result cache, I use less CPU than if I just use the result cache. So scalar subqueries are really cool. If you've heard Tom Kite talk about this subject, he'll probably say you should always write function calls as scalar subqueries just in case. And it's quite a good rule to follow. So for ultimate performance, you're probably going to want to combine another form of caching with scalar subquery caching and get the best performance you can. Is there anything new in 12c to do with caching like this? Well, actually there's not, but there's something else that's quite interesting, which is the with clause has been extended to allow PLSQL definitions. This is useful because this PLSQL has a slightly different call specification, which makes it more efficient to call from SQL, which means we have much less of a problem with context switches. So it's not caching, but it will improve performance. We can also use this alteration to the call spec using a pragma called pragma UDF, user-defined function, which alters our packages or our stored functions or stored procedures to have a different call spec. But you should only really do that if you're using them from SQL. Very last points. What about PLSQL called from the from clause and the where clause? Well, if it's in the select list of an inline view or the with clause, the same rules apply to what I've just shown you. Exactly the same. If you're using a table function in the from clause, you should probably switch to using a pipeline table function because it pushes the rows out as they're generated. You don't build a big collection in memory, wasting lots of memory, and then throw it all out. So they're much better. Scalar subquery caching should be used wherever you can, in the where clause, in the select list, anywhere you can. And avoid functions on index columns if you can. because if you put a function on an index column, then Oracle can't use that index. You can get around that by using a function-based index, but they take more management. So you have to run the function for every insert or update on the row to get the value to put in the index. So the maintenance is heavier. I'll miss out that demo as well. So what did we cover? Scalar subquery caching is great, and it's been available for ages. It doesn't cost you any money, it saves you money. Deterministic hint is nice, but it can be confusing because of the way it caches just for the lifetime of the call, not for the whole statement. Cross-session PLSQL result cache, really cool, definitely start playing with that, like it a lot. Manual caching, if you're on a version prior to 11G, is possible. Functions are used in the from clause, where clause. There are ways to make them more efficient. Now, I have this website called oraclebase.com. On that website, there's a really plain page. You probably can't read that, but it says oraclebase.com/workshops. And on that page, you can get the slides, the PDF, or an article link for everything I'm presenting today. If you were to click that article link, you will see this article, and it's got everything I talked about today, plus the bits I had to miss out. And it's got a little translate button there, so you can Google translate it to the perfect Spanish. Okay? And if you were, why would Google lie? Okay. And if you want to see the demos again, I have a YouTube channel, and on that YouTube channel there is a playlist called Efficient Function Calls from SQL, and you can see all of those demos with me talking and hear my boring, repetitive voice once again. Okay. So, I'm going to leave it there. I think I've saved us a bit of time and got us back more on time for the agenda. So thank you very much for coming. If you don't really like SQL and PLSQL, what's wrong with you? And I'm really sorry you've been made to sit and listen to me. But if you do like it, I love to talk about this stuff. Come and speak to me during the day. I love speaking to people about technology. And I've got a session right at the end of the day about running databases in the cloud. Thank you very much for coming.
Me parece que sigue en la línea de base de datos, y pues ahora vamos a tener la presencia de Cameron, que él pues es un ACE Director, como lo mencionaba Pablo, de este grupo o el programa de los Oracle Aces, y pues de nuevo él va a dar su presentación en inglés. Cualquier observación, duda, me parece que pueden libremente preguntarle durante la sesión para hacerlo lo más interactiva posible. So thank you, Cameron, and
thank you.
You're ready to go.
Thank you. Sorry. Hello, everybody. First of all, I would like to thank for inviting me to Mexico, and thank you for coming to this session. Today, I'm going to talk about Oracle 12c ASM new features, and I will show you a few practical demonstrations. But before starting my presentation, I would like to introduce myself. I'm Cameron from Azerbaijan. Is there anybody who heard about my country? Oh, yeah, you know it. Okay, so let me show you in the map. I'm from Azerbaijan, located at Eastern Europe, and is bounded by Caspian Sea, by the Russia, by Iran, and by the Turkey. So I work as a DBA team head at Azercell Telecom. I'm Oracle Certified Master, and Oracle ACE Director, the only ACE Director in Azerbaijan. I'm also working at CommonArchive.com, and I'm President of Azerbaijan Oracle User Group, not the Azerbaijan. A few years ago, I published a book about ARM and backup and recovery, where you can find a lot of backups and recovery techniques with a lot of practical examples. Now, the next month, my next book will be published, and it's already available in Amazon for the pre-order, and it's about how to pass the OCM exam. This is the only OCM exam study guide that is available in the market for now, which is related with Oracle 11G. So it has around 700 pages, and you can find a lot of practical scenarios where I show how to implement specific tasks. I provided more than 200 practical scenarios, and for each topic of the OCM exam, you can find a lot of tasks assigned by me. For example, during the OCM exam, you might get a task to create a database, but being a DBA, you only created a database using a database configuration assistant. Like next, provide database name, etc., and click finish, that's all. The database is ready. But they can ask different questions. I mean, they can ask to create a database in a silent mode. And if you haven't done it before, it would take a long time to find a silent installation, database creation, the documentation, and try to do it in the OCM exam where you are fighting against the time. I'll show you a lot of practical scenarios, and for each topic, I assign a task for you. For example, go and create a database in a silent mode with these parameters and do it in 8 minutes. So if you cannot do it in 8 minutes, most probably you will fail this exam. So that's why there are a lot of more than 300 practical tasks that are assigned to you with a specific time limit in order to make you prepare for the exam and pass it successfully. So I also train Brazilian Jiu-Jitsu. Is there anyone who trains Jiu-Jitsu? No one? Okay, that's good. So I participated in a lot of competitions, and 2 years ago I became the champion. A lot of guys say that this is a Photoshop. I put myself to that place, but I can prove them wrong, or anybody, with not the practical demonstration, but with a video I think it will run. Oh no, it's not running. Let me show you, because I don't want you to ask me hard questions during this session, and that's why you have to see this video. This is me competing in a tournament. So in Jiu-Jitsu, you have to take control, and you have to get some points and submit your opponent. Yeah, I tried to submit him, but I won this match with points. And the next match is from the World Championship, where I lost my second fight, but I won this fight with a submission. This was my first tournament. I was lucky. You can see it in a slow motion, where I catch his arm and try to break it, but he taps. This is it. Okay, thank you for coming. This was all about Oracle Tour. Thank you. Okay, now let me proceed to the session, why we are all here. Okay, I would like to ask you some questions, guys. How many of you use ASM? 1, 2, 3, 4. Oh, a lot of people. Good. So how many of you run the production database on ASM? 1, 2, 3, 4, 5. Great. And how many of you have used any of Oracle 12c ASM new features in the production environment? Oh, great. 2, 3, 4. Okay. That's why I'm here. The Oracle ASM was first released with Oracle 10G. And we provided a significant simplification of the usage of the file system, where you can add and drop the disks online. And there are different utilities that can be used to administer the ASM, such as SQL+, Oracle Enterprise Manager, or the ASM CMD. But starting from Oracle 12c, Oracle introduced a lot of new features, such as Oracle Flex ASM, Oracle ASM Interconnect, which is the dedicated ASM network, and there are a lot of new features that comes with related with ASM disk group new features, which are failure group repair time parameter, ASM disfair, handling enhancements, faster de-stressing, and etc. So let's talk about the Flex ASM. Prior to Oracle 12c, if we're having a number of nodes, each node we're having a RDBMS instance and the ASM instance. And the RDBMS instance were highly dependent on the ASM instance running on the same machine. If the ASM instance fails on that machine, the RDBMS instance would fail. To solve this problem, Oracle 12c introduced a new feature which is called Flex ASM, where the RDBMS instance of any node can connect to any ASM in the entire clusterware. In order to enable the Flex ASM feature, we have to enable it during the grid infrastructure installation and check the parameter use Oracle Flex ASM for the storage. To get information about from the ASM if you use the Flex ASM mode is enabled or not, run ASM cmd show cluster mode command. So here we get the output that the Flex mode is enabled. To get the list of the ASM instances running in the entire clusterware, we run server control status ASM detail command. So here we have configured 3-node rack, and we have 3 ASM instances in the entire clusterware. Starting from Oracle 12c, you can configure the count of you can modify the count of ASM instances that are going to run the clusterware, and which is called the ASM cardinality. So it means that the ASM cardinality, here we can run server control configure ASM command, and we get that ASM instance count is free. This means that we can run 3 ASM instances in the entire clusterware. Anytime you can modify this parameter. Sorry. So here we run server control modify ASM command, provide the count parameter, and decrease the ASM cardinality from 3 to 2. Oracle will automatically shut down one of the ASM instances in the clusterware, and that RDBMS instance that we're running on that node will be connected to another ASM instance. After running this command, we run server control status ASM detail command, and we get that we have only 2 ASM instances for the clusterware. If we try to start it, we'll fail because the cardinality was set to 3. We have, for 2, and we want to start the 3rd ASM instance. In order to start that ASM instance, we have to modify the cardinality, increase it from 2 to 3, and start that ASM instance. It is not started automatically, so we have to start it manually. So now I would like to show a video tutorial. I would like to show it live, but it will take a lot of time to stop the ASM instance, to change the cardinality, and to see what happens. But I created a video tutorial. I cut and edited it, and would like to show you how the Flex ASM works. But before getting into it, let's see some slides, and let me explain you the process in detail. So imagine that we have 3-node cluster, and each node has its own database and ASM instance running. So if we run this command server control modify ASM count 2, the Oracle will automatically stop one of the ASM instances and will bring it down. So in this case, it brings down the ASM free instance. And the database instance will automatically connect to any available instance in the entire clusterware. Next, we run, so if we check the out log file, we'll see that the ASM free instance was deregistered from the clusterware, and the database instance is connected to the second ASM instance. If we query gd.asm client view, we can see which database instance is connected to which ASM instance. In this case, the 3rd database instance is connected to the second ASM instance. If you run the same command and decrease the cardinality from 2 to 1, the Oracle will automatically bring down another ASM instance, and that database instance will connect the all available instances in the clusterware. So there will be no downtime. Oracle will do it in the background, and the database instance will connect to the ASM instance. If we try to check the ASM instance running in the entire clusterware, we'll see that we have only one ASM instance. If we check the RS log file, we'll see the database instance is connected to the second ASM instance, and we have only one ASM instance available in the entire clusterware, but we have 3 database instances running. So let me, if you increase the cardinality, or if you put down the failed ASM instance again, the database instance will not automatically connect to the ASM instance. You have to do it manually. So you have to relocate that database instance to its ASM instance by running alter system relocate client command. In this case, we relocate the first database instance to use its own ASM instance. And you see that the RackDB1 was connected to the ASM3, but after bringing the ASM1 up, we relocated that database instance, and now it is connected to its own ASM instance. So now let me show you how it works in a video tutorial. Okay, we run ASMCMD show cluster mode command, and we get that the flex mode is enabled. So we get the status of the ASM instances running in the entire clusterware. We got that we have 3 ASM instances running in the 3-node cluster. Yeah. I'm sorry, not because I don't have such a tool to. You cannot read it. What if we turn off the light? Can we turn off the light somehow? Anybody's there? Stop sleeping? It's too bad. No? We cannot turn off the light? Switch off the light? For a few minutes? Maybe you can make it dark or up. Oh, that's good. You can see it? You can see this, right? Okay, it's okay. It's okay. Thank you. Gracias. Okay, so the flex mode is enabled, and we have 3 ASM instances running in the background in the clusterware. We run server control config ASM, and we get the cardinality, the ASM cardinality. And we run, we query G with the ASM client view, and we see that each database instance is connected to its own ASM instance. Each of them is connected to its own database instance. Now we'll change the ASM cardinality and the server control modify count. So the Oracle shut down the first ASM instance. And you see RackDB is now is connected to the ASM, to another ASM. So when we decrease the cardinality, change the cardinality, Oracle automatically shut down the first ASM instance, and that ASM instance, that database instance is connected to the second ASM instance. Here, because the flex mode is enabled. Here we can see RackDB1 is connected to the second ASM instance, right? Okay, now we will change the cardinality again. So we log into the first node, we get the S1 processes, there is no ASM available, but the database instance is running. Okay, now we bring the cardinality, we change the cardinality and make it 1. Oracle will automatically shut down the ASM free, I guess. Okay, the database instance is now connected to the third ASM instance, ASM free. Okay, so we have only one ASM instance and 3 database instances. All of them are connected to the third ASM instance. And nobody knows about it. When I was presenting this session a few months ago in Finland, a guy came to me and he said that we were running a 6-node 12C clusterware for one company, and one of the ASM instances was shut down 3 months ago abnormally, and we didn't know that because it was using the Flex ASM instance, Flex ASM feature. So they didn't know that. Okay, now we get the status of the instances running in the clusterware. There are 3 database instances, right? If we get the status of the ASM instances running in the clusterware, we have only 1. Now we try to start the ASM instances, but the cardinality was set to 1, and it will not be able to start it. So we have to change the cardinality and then start that ASM instance one by one. We change it to 2. It is not started automatically. We have to start it manually. So we run server control start ASM, specify the node, and it is up. So now we have 2 ASM instances. If we run the same query, we'll see that the database instance is not relocated to its own ASM instance. It has to be relocated manually by using author system relocate command. The RackDB1 still uses ASM free, right? So we log into SQL class, author system relocate client, we specify a RackDB1 instance. It is relocated. Now if we run the same query again, we'll see that the RackDB1 now uses its own ASM instance. We try to start the third ASM instance. We fail because the cardinality was set to 2. Now we increase the cardinality and start it. Okay, the status of the ASM instance will not. We have 3 ASM instances running in the background. Now we query GDDO ASM view. Again, we have to manually relocate it. Okay, now everything is fine. Okay. Okay, ASM instances running in the nodes of the cluster where have to communicate among themselves to transfer the metadata information. Starting from Oracle 12c, you can use a dedicated private network for the ASM network traffic. When you install the grid infrastructure, just the specify ASM and private. So this network device will be used will be used for the ASM metadata network traffic. So I've shown you that if we use the Flex ASM feature, any database instance can connect to any ASM instance. When this happens, Oracle used the password file. So starting from Oracle 12c, any database instance can connect to ASM instance, then they use the password file. When we install the grid infrastructure, the password file is created automatically under the password folder in the ASM directory. In order to get the full location of that password file, we run a pw get command with the ASM parameter. Starting from Oracle 12c, you can change the password of the ASM instance by using ORapBD utility. If you provide the ASM equals y, you can provide a new password for the ASM. And and you can connect from any node to any ASM instance using the SQL Plus because of the password file. With regard to the ASM password file feature, there are some new ASM CMD commands that were introduced in Oracle 12c. Using the pw copy, you can copy the password file, you can delete the password file, or you can get the location of the password file. You can move the password file to a different disk group, or you can set the location of the password file for a new disk group. And you have a few more ASM CMD new features where you can get the version of the ASM that you are running, show the cluster mode if it's using the Flex ASM or not. Moreover, you can use the help command to get more information about any command of the ASM CMD, and it will provide you with detailed information on how to use this feature, and it will provide you with example at the end. So if the ASM password file is not available, then the clusterware will not come up. And you will get this error while accessing the physical storage. I got this error a few months ago in my test environment, and I was just, what's happening with my physical storage is everything is okay. I don't get any error regarding my physical storage. And what does it mean invalid username and password? So this error means that your password file is lost. In order to restore your password file, you get the location and copy the password file from the backup to that location. To get more information about how to restore the password file, just use the mentioned metalink node. Okay, when we created this group, we provide a path of the physical disk, and internally Oracle assigns a disk name for each disk. Normally, we don't need to worry about the disk name because it's assigned automatically. But there might be a case when you might be moving the storage from one place to another, and you have a lot of ASM disks, and you would like to have the meaningful ASM disk name in the disk group. So in this case, you will not be able to rename and assign a new disk name for the disk. So prior to Oracle 12c, even in Oracle 12c, when you create a disk group and use the disks, the Oracle internally assigns the disk name, mydg00, 001, etc. So starting from Oracle 12c, you can rename disk names using alter disk group rename disk command. In order to rename a disk in the disk group, you have to dismount the disk group and mount it in restricted mode. So here we rename 2 disks and then query visual ASM disk view, and we get the new disk names. So one of the biggest advantages of using ASM is the ability to replace disks online. So before Oracle 12c, we were having 2 options. Either we were adding a new disk to the disk group with 2 commands and then dropping the disk, right? Or we were using both commands in as a same command, as a single command, and we specify a new name, a new disk, and we specify the old disk that should be dropped. The only problem with this command is when we run this command, the whole disk group rebalance will occur. So if you have a huge disk group and you want to add a new disk and drop the new disk, replace the disks, the whole disk group rebalance will happen. So starting from Oracle 12c, you can use alter disk group replace this command and replace and provide the disk names, and the whole disk group rebalance will not happen. The rebalancing will happen only between the mentioned disks, and you will gain a lot of time. So it was not possible to give the time that will take for a specific ASM command before Oracle 12c. But imagine that sysadmin comes to you and tells you that we want to drop some disk and we want to add some disk. How much time it will take for this process? And you're just like, I don't know, it will take an hours, or it might be happen in minutes, but you don't know. You cannot estimate it. Starting from Oracle 12c, you can use video ASM estimate view and run explain work for command and provide the command that you are going to run. And Oracle will estimate not the time, but the count of allocation units that the count of the allocation units that will be removed or will be deleted or will change. So if we run alter disk group add this command, there will be changed in 24 allocation units. And using the count of the allocation units, you somehow can forecast or can estimate the time that will be using for this command. The faster racing, when using a normal or high redundancy, this group that the allocation units are mirrored between the failure groups. So when a disk temporarily offline in a normal or high redundancy disk group, it needs to be replicated back when it is online. This process is called faster racing. So starting from Oracle 12c, we can specify the power limit, because this process can consume a lot of time. Imagine that you have a failure in the storage of any failure group, and that failure group is offline, and it took 10 hours to solve that issue, and you online those disks and those disk group, and it will take a long time to copy the change from the second failure group to the failed failure group, right? Starting from Oracle 12c, you can specify the power limit when onlining the disk using the power command. And there's a next good feature related with the fast racing, which is the racing is completely restartable. ASM use checkpoints to store the last point of the resync and will restart from there. So if this command fails after 2 hours, you will not lose your 2 hours, or because Oracle will use the checkpoints to store the whole process and will start where the command is failed. If a disk is offline in Oracle ASM because of an IO error, or you just manually offline the disk using alter disk group offline this command, that those disks will be removed, will be dropped automatically after 3.6 hours. Because I have a problem with the microphone, I guess. Okay, no problem, you can hear me. Because of the disk repair time parameter. The default value is 3.6 hours. So look at this case, we create a disk group in normal redundancy, where we set the attribute of disk repair time to 1 minute, and we don't drop the disk, we just offline those disks. And after running this command, you'll get a message in your Outlook file that disk 1 in group 2 will be dropped in 1 minute. The default value is 3.6 hours, but if you change this attribute, we change in this case to 1 minute, so it will be dropped in 1 minute automatically. And you'll get this good message after 1 minute that the alter disk group drop disk command with force option is performed. You didn't drop the disk, you just offline those disks. So, but what happens if the whole failure group fails? Imagine that you are using Exadata, you are using the two failure groups. You are using a normal redundancy. You have two failure groups, and there is a problem in the storage in the cable of the storage of one failure group, and the whole failure group fails. So what happens in this case? After 3.6 hours, all offline disks will be dropped automatically. So this is a huge problem. Despite the fact that we are using the normal redundancy, when you will add those disks, the rebalance process will happen, but it will take a long time. Starting from Oracle 12c, Oracle introduces a new attribute, which is called failure group repair time. So even if the whole disk group became offline, the disks will not be dropped automatically and will not be dependent on the this repair time parameter, which is 3.6 hours, but will depend on failure group repair time parameter, which the default is 24 hours. So in a normal or high redundancy disk group, a copy of each allocation unit resides on the different failure groups. So if any corruption is detected, and the database automatically recovers by reading the mirrored copy of that data. Now I will show you a video tutorial about this feature, about how this feature works. Then I will show you the ASM Oracle 12c new feature related with this feature. But before moving the video tutorial, I would like to show you some slides and explain the whole scenario. So in this scenario, we will create a normal redundancy disk group, and we will corrupt a single block of one of the disks, and we'll see what will happen in the background. So fortunately, this is the first session of the day, and I remember that in the next year, in November, I presented this session in India after the lunch, sorry, and all of the participants were sleeping, and I was showing a scenario with a lot of mathematical cases, and all of them are shaking their heads, sleepy heads. Fortunately, you are not sleepy, and it's not the after lunch. So here, what we are doing is we create a disk group in normal redundancy, provide two failure groups, each disk in one failure group. So we'll create a table space on that disk group. We create a table, we insert one row, we commit the transaction, flush the buffer cache to make sure that our row locates in the disk, and query the table. Then, as we are going to corrupt a single block in the ASM, it's very easy to corrupt a single block in the file system, but it's a little bit hard to find that exact block and corrupt it in ASM. So, in order to find at which block my row locates, I will use a util encode package, and against that table, I query the table from MIT, you see, and get the output that that row, which is my test, locates at the block number 135. So it is not a file system. We cannot go to the 135th block and corrupt it. We have to do some math. So the block I need is 135. We also know that the size of each allocation unit is 1 megabyte, which is 124 kilobyte. 1024 kilobyte. And we also know that the database block size is 8 kilobyte. So we can find that we have 128 blocks in each allocation unit, right? So if our block locates in 135th block, it means that our block locates in the second allocation unit and on the 7th block. Then to get the exact number of the allocation unit, we get the file number from the video ASM file, and we query xstore key ffxp view table, which is the internal table, and get the list of the allocation units of that disk group, right? So the second column indicates the number of the allocation unit. So we don't need the first one, we need the second one. So the third column indicates if that allocation unit is the primary or the secondary, because we are using the normal redundancy and we have two failure groups. And there we can find that we need the second allocation unit number, and its number is 53. So our block locates at the allocation unit number 53. So you can use strings command to make sure that the data we need to corrupt locates on both disks. Just run the strings command against both disks, grep my test, which the row I inserted right now, and we can get the output. So our block is there. Now I will run the dd command, and I will get the one allocation unit, count 1, and I provide the size of the allocation unit, which is 1 megabyte, 1024 kilobyte. I skip to the allocation unit number 53 and dump that allocation unit to the file tmp aud1. Then I use strings command against that file, and I see that I dumped the correct allocation unit. So we can go further. Then I will dump only one data block, count 1, and then provide the size of the data block, which is 8 kilobyte, and I skip to the 7th block because our block locates at the 7th block, and I dump that output to the file. Then I query from the output, and I get the my test. So we are on the right track. Now, so let's recap what we have so far. The size of the data block is 8 kilobytes. The allocation unit number is 1 megabyte, which is 1024 kilobyte. The total amount of the blocks in the allocation unit is 128. So we distract that value, we get the block number 7, and the allocation unit is 53. So if we multiply the allocation unit to 53 to the count of the data blocks per allocation unit, and plus the 7th block, we'll get the exact number of the block where our block resides in the disk, not in the data file. So the block number is 6791. Now we use the dd command again against the ASM disk. We get only count 1, just one block, 8 kilobyte, and skip to the specific data block and dump the output, and we get the my test. So now we can corrupt that block easily. So before corrupting the data block, I would suggest you to use the same command and add OD command to get the output of the whole data block and see if your data is there. So we dump that block and we see my test is there. So now we can easily corrupt that block. Please don't try it in your production environment. I don't want you to get any failure. You will not get any failure, but don't try it. So we'll corrupt that block using the dd command. I run this command, dd if dev 0, I provide the ASM disk name, I provide the 8 kilobyte, one block, count 1, and provide a block number. So the block is corrupted, congratulations. And I dump the output file and I will get the nulls. I will get only null, not my test. So after corrupting the data block, I will query the table and I think that I will get this message, but fortunately not. I will flush the buffer cache. I will take my gun and put it in my head because I corrupted a block in my production environment and query the table and I get the output. So Oracle, what Oracle perform in the background, will check the alert log file, we'll see the corrupt block is detected. Oracle tries to read data file 7, block number 135, but it cannot read it from the first disk. But it was able to found the valid data from the second disk. And then we'll see the output that the repaired corruption. So the Oracle automatically repaired that corruption by reading the valid data from the failure disk group. We run the same command again, dump the output of the block, and we'll see that my test is there. So it is repaired automatically. So in Oracle 12c, you can use a new command called scrub to read out the logical corruption for the whole disk group or for a specific disk. Because the Oracle repaired that corruption because we queried that table, and Oracle detected that corruption and then repaired it. So what happens if the same block in the second failure group also corrupted? So in order to not get those corruptions, it's better to run scrub repair command against the disk group or against individual disks. So out of disk group, my DG scrub repair will try to find and read out the logical corruption for the whole disk group. If we run alter disk group scrub power, we can power max consumes the most resource to complete the command faster, but may affect other operations in the system. You can use power auto to let the ASM choose the best power value depending on the system resource availability. Or we can use alter disk group scrub disk command and provide the specific disk name, or we can provide the path of the specific disk name and let RMAN to check if there's any logical corruption and repair it. Okay, that's all about Oracle 12c ASM new features. Thank you for coming. If you have any questions, please ask. Muchas gracias.
Yes, I have a question.
Oh, sure.
Your Flex scheme.
Uh-huh.
What's the problem with the online in the next ASM instance? Is the problem to performance in database? You connect to remote ASM?
Actually, I haven't checked the performance of the data. Oh, sure. The question is that if you're using the Flex ASM and one of the ASM instances fail, the audience instance will connect to the ASM instance, another ASM instance cluster where what kind of performance issues you have. I made a research in the Metallic notes, but I haven't found any performance issues related with the Flex ASM. There might be, but I haven't discovered it. Any question? Okay. Thank you.
Can you choose which instance is going to be shut down?
I don't know. Okay, this is a good question. Actually, normally you don't play with the cardinality of the ASM. But if you want somehow to bring any instance down, you just run server control, stop the ASM instance, and it will stop that ASM instance. You don't have any control against the command server control when you modify the cardinality. The Oracle internally decides to shut down any ASM instance in the entire clusterware. You don't have any control over that command.
Thank you.
Welcome. Okay, done. Okay, now is the next section, right? It's yours? Oh, sorry.
Hola a todos, buenos días. Desafortunadamente, yo no hablo español, solamente portugués e inglés. So this session will be in English. My name is Alex Zabala. I'm Oracle Director from Brazil. This is why I don't have time to learn Spanish, because I spend my time doing certifications. The last one was the Oracle Certified Master 12C. You can find me on all social media, like LinkedIn, Twitter, and so on. This is my blog. I work as a developer for 7 years in Brazil. I used to work with forms, reports, SQL, PL SQL, from 2000 to 2007. In 2007, I moved to Angola. It's in Africa. I work for the Ministry of Financials. In 2015, I went back to Brazil, and I'm now working for Enctech. Enctech is now part of Accenture. Today we'll talk about the 12C new features, more related to tuning features for developers and DBAs. How many people are DBAs here? Okay, developers? Okay. So the best source of the new features for Oracle is the official documentation in the Oracle Learning Library. And also the Oracle base from Chin Hao, a lot of good articles about 12C. So on 12C we have like 500 new features. I choose like 20 to talk today. About 12.2. I am one of the beta testers for 12.2. Unfortunately, I can't talk about this because it's confidential. What I can talk is the public information. So on 12.1 we have 252 PDBs. On 12.2 it's now 4,000. Another thing on 12.2 is hot cloning. So you don't have to close your PDB to clone or put it in read-only. You can do online. Sharding. Sharding is a new concept for the Oracle database. It's the opposite to real application cluster. On the real application cluster we have the shared storage, the same storage for all the instances. Sharding, we can have your table split in different countries. For example, I can have my data, one partition in Brazil, one partition in US, and one partition in Europe. In memory improvement, on 12.2, you can now using memory on the active data guard for reports. And we have now rate map for in memory. This is the new concept, application container. So imagine that you have like EBS or SAP application, and you have the same package in different PDBs. With this new concept, you can update just one, the application container, update the version of your package, and all the other PDBs will see automatically the new version of this package. So 12.2 availability, probably the next open world, maybe in October. The good news, the extended support for 11.204. We can use 11.204 until May 3rd. So let's start. Multi-tenant. This is a big improvement on 12c. What do you think? Is it a tuning feature or not? Yes? Not really, but I'd like to show you this. So, non-CDBs with 20 giga of memory, I can have like 50 databases. On the new concept, I can have 250 databases with the same 20 giga. Be aware, the non-CDB is now deprecated on 12.102. So in the future release of the Oracle database, we will have no option to use non-CDB, just CDB architecture. Is it a problem? Not really, because deprecation does not mean desupported. If you remember the data type long, it is desupported for a long time ago, but long data type still existed in database 12c. This is some features, and this feature is not working on CDB architecture. It will probably be working on 12.2, but it's not working on 12.1. In memory, it's another feature on 12.1, the big one. So basically, in-memory is not invented by Oracle. It's a concept in the marketing, and Oracle created the in-memory product because of the SAP HANA. What do you think? Is it a tuning feature in memory? Yes? Yes, it is, to speed up your reports. In memory is just a static pool in the SGA. To enable, you just have to set one parameter, the size of your in-memory, and when you restart your database, you start to see this in-memory area. To use, you have to do like alter table name, in memory. You can do just for one partition, or you can enable for entire table and disable one partition, or we can enable for entire table and disable for one column, or you can do it at the table space level. Skip this. Let's start. Before 12c, to see the top queries, you have to use something like this. You have to put your query, use the order by here, and use the whole num outside of this query. On 12c, we have a new syntax. You can use just this, fetch first 5 rows, and the order by is here. Or you can use 30%, or bring me 2 rows after the first 2 rows. Can you read this? I think I can make it bigger. Better, no? Okay. I'm creating just a simple table, ID, name, and salary. I have 10 names here and the salary. So before 12C, you have to use something like this to get the top 5 salaries in the company. And now, sorry. I can use this new syntax to see the 5 top salaries of my company. I'd like to show you the difference in the execution plan. Before, we have here a count stop key. And now we have a window function. It's an analytic function, and it's much faster using this way than this way. I can do something like this, bring me 30% of my table, so just a row. Or bring me the next 2 before the previous 2. Approximate count distinct. This is a new function on 12C. Before, I have to use count and distinct here. Now I can use this new function to see exactly the same results. So let's see how long it will take to bring me the result. So it's 13 seconds. Actually, 12 seconds. So this one is much faster, but look this. We have 10,000 here, and we have 10,050 here. So it's much faster. Where is it? But it's not exact result. If you are working with some systems, you don't need exactly the result. But if you are working with the financial system, please don't try to use this, because it's not the exact result. PL SQL from SQL. So in the previous session from team, he showed how it works. So using this way is much faster, because you don't have to switch between the SQL and PL SQL. But there is another thing. If I'm working in a customer and I can't create new objects in the database, because it's a production system, there is some rules, I can use this way to use function or procedures. this better. So I'm using this function to see if the row is numbered or not. And it took like 6 seconds to run. So how can you see here? I'm using this function, is number, but it's not in the database. Now I use the same, but this is a function inside the database. It's the same one. Sure. Now I'm using is number 2. I'm sorry. So the previous one took 6 seconds. This one will take like 20 seconds. So this is the difference between switch to the context between SQL and PL SQL. Here, 21 seconds. Exactly the same function. One is inside the database and the other is not. Session level sequence. We can use to generate values for primary keys on global temporary tables. So every time you log and create a new session on your database, the sequence will be reset. How can I do this? Create sequence, and I can use the keyword session. Or I can use alter sequence to change an existing sequence to session or go back to global. So I'm creating a new sequence, session sequence. So the next val is 5. When I open a new session, it will start from 1 again. Oops. So let me show you the difference between the time I'm creating the regular sequence here, sequence 1, and the section sequence is the sequence 2. Seven seconds with the regular sequence. With the new one, two seconds. So the difference here is because the Oracle doesn't need to update the data dictionary with the last value of the sequence. Now on 12C, we have the session private statistics. So on 11G, the statistics are common to all sessions for global temporary tables. in now on 12C, we have an option to set the preference to session. How can I change? Set global preference. It's valid for all the database. Or I can set just for one object, like for this table. This is session, this is shared. Temporary undo. We have now an option to generate even less redo for global temporary tables. You just need to set this parameter, temp undo enable to true. Let me disconnect here. Okay. So in the first test, this parameter is disabled. Let's run this insert and look this number. Reduce size. So I'm now changing to true and look the redo size. It's just 420 and here is 292,000 bytes. Just setting one parameter to true. Multiple index on the same set of columns. On 11G, if I try to create an index in the same column, I got this error. So the question is, why should I create the same index on the same column? And the answer, if I want to try to test unique index versus non-unique, or test on a B3 index versus a bitmap index, or different partition strategies. So I'm creating just a simple table. I'm creating now a unique index. And now I will try to create a non-unique index. So I got the same error. Why? Because I can have only one index visible. Now I have two indexes on the same column, column 1. One is visible and one is invisible. So now for the column 2, I have a regular B3 index and a bitmap index. So in this case, I have a table access full. Let's change it to my ZRC, the invisible index now. And now I'm using my new index, my bitmap index. Limit the PGA. So in 11G we have the PGA aggregated target, but this parameter is not a hard limit for the PGA. On 12C they introduced the PGA aggregated limit, and this is a hard limit for the PGA. So your database cannot have more than, in this case, 2 giga of the PGA. Statistics during loads. This is an improvement on 12C. When I do a direct path insert or bulk load operation, like create table as select or insert append, the database will automatically collect the statistics for me. So now I have the statistics for this create table as select. You can see a new step on the execution plan. Here, optimizer statistics gathering. And the same happens for inserts with the hint append. We have optimizer statistics gathering here. So in some ETL structs, we'll have to load the table and at the end collect the statistics. So it's 2 steps. And now it's just 1. So it's much faster. Partial index for partitioned table. Now I can disable the index for some partitions. Imagine you have historic information on your database and you don't query this information much often, like you have data from 2000, 2001. You can disable the index for this partition and save some storage space. Full database caching. Nowadays, with the power of the hardware, sometimes we have more memory than the database size. So if you have more memory than your database size, you can use this feature to enable to have all your database on your SGA. Adaptive join method. This is very nice because now the optimizer can change on the execution time from a nested loop to hash join and from a hash join to a nested loops. I just have to have these adaptive features true. This parameter report only to false, and features enable to 12.1.01. This is just a simple example. On explain plan, I'm expecting a nested loop, but my final plan is a hash join. Real-time SQL monitor. If you have license for diagnostic and tuning pack, you can add this hint to your query, or for all parallel statements, or for statements that took more than 5 seconds. You can see on the Oracle Enterprise Manager Express on 12C, go to performance, and you see something like this. It's in real time. So your query are executing, and you can see all the information in real time. this is something nice. You can click here, show your binds, and you see all the values for your bind variables here. You can do the same on the SQL developer. Go to Tools, Monitor SQL, and show SQL details. You have the same information on SQL developer. Or you can do on command line using this package, dbms SQL tune, report monitor. You can use in this way, just pass the SQL ID, and you have a HTML file with all the information about your query. So, what time is it? We have 3 minutes to finish. Questions? 5? Okay, let me show you something cool. What happened? Here, let's make it bigger. Here, we have this new tool, SQL. It's called the SQL Plus on steroids. It's from the same team that built the SQL developer. So you don't need to query the user table to see your tables. Just type tables, and it brings all your tables. Yeah. You don't have to use desk. You can use info. So the info is much power. You have a lot of information like the index, constraints, and everything. Or you can use info plus. And now you have much more information with like statistics, histograms, and etc. For create table as select, I can just type CETAS, my source, my destination, and it creates the scripts for you. If I need to extract a DDL from my table, I can just type table, I can type DDL and my object name. I can disable the segment attribute. Just the create table without the table space information. Cool thing, I can go up and go down and change my comments. I have an history. I can check an error, like Ora 600. I can set formats like CSV. Oops. Let me change the table. So I have the CSV format here, or I can change the format to XML. Now I have my data in XML format. I can have JSON format here, just a hint. I can have some colors in my scripts. I can have something like this to check my table space. Green is okay, yellow is warning, and red is a problem. So you can go to the website, SQL Developer website, download it. It's free. It's very nice. Just try. And also, the Oracle base, a lot of good articles about 12c. On 12.1, we have like 500 new features. About 12.2. 12.2, I am one of the beta testers for 12.2. Unfortunately, I can't talk about 12.2 because it's not allowed by Oracle until the public release. This is all the public information. So in 12.1 we have 252 PDBs. On 12.2 we have 4,096. On 12.2 we will have hot cloning. You don't have to close your PDB and open in read-only mode to clone. It's also valid for the cloud. You can clone your local PDB, your local database to the cloud online. Sharding. Sharding, it's a new concept. I heard that Oracle is implementing sharding on the Oracle database for Apple. Sharding is opposite to the real application cluster. On real application cluster, we have just one storage, and all the Oracle instance access this storage. In sharding, we have a lot of storage in a lot of places, and you can have like one table and one partition of this table in Brazil, another one in US, another one in Europe, so you can split your data around the globe. In memory, on 12.2 you can use in memory on the active data guard, and you have now heat map for in memory. The application container, you have just one location for your object of your applications. Like if you have a SAP or EBS, you have just one location and you update just one location, and all your database, your PDBs will see this application container with the new version. 12.2, we are expecting for the next open world. And you can use the 11G, 11.204 until May 31 of 2017. What do you think? Upgrade to 12.1 or wait for 12.2? Upgrade to 12.1? Wait for this. Okay. Using multi-tenant CDB? No CDB? Okay. JSON. JSON is now is a new feature of 12c. We have XML. This is a little example. And JSON is this format. It's the same information in different formats. How can you use JSON on the database? You have to use this new constraint, is JSON. for this column, the new constraint, and you can insert data. So I'm creating a simple table here. I can check this new view, user JSON columns, my table name, my column name, and my data type. So I can insert some values in the JSON format. If I try to insert, this is not the JSON format, I got this error because it's not a JSON format here. To extract the information, this is a new syntax, my table alias, my column name, and my JSON tag here. Happen here. Okay. So I'm now creating a new table, JSON2, just a normal table without the constraint. I'm inserting JSON value, and just a string here. Then I can use on my where clause is not JSON, is just record, or is JSON, is just record. So this is a new syntax for 12c. To index this column, I have to use the Oracle text. And you can see here the index, my Oracle text index, when I try to find some in this column. Data reduction, a new security feature on 12c. It's part of advanced security, so you have to pay to use. And the good thing, we don't need to change our application to use the data reduction. So this is a credit card information. This is my table on my storage. This is the authorized display. And this is the guy, looks like the guy of the call center. When we call to our credit card to ask for some information, they ask us for the last 4 digits of the credit card. We can do this using the data reduction. Let me show you a demo. So I'm creating here a new user demo, with a simple table. This table with my credit card information, ID, customer name, card number, date, and security code. So let's fill this table. So I'm using now sysdba user. I can see all the information about my credit card. Let's add a new policy for this table. So what I'm doing here, for my new tab, for this column, I choose the reduction full. The expression is, if my user is user demo, apply this policy. So I'm now connecting with my demo user. So my demo user is not able to see my card number here. I can change this policy from full to partial to see only the last 4 digits of the credit card. In this case, from the first 12 characters, I will see the number 9. What I'm saying here, 99999 in only the last 4 digits of my credit card. So I don't have to code my application. I can do this on my database. Invisible columns. Now on 12C I can create a column, invisible. When I try to describe this table, it's not here. To insert values, I can reference this column, or without reference, I can insert the values. To see the invisible columns, set column invisible 1, it's here. And I can make it visible again. So the question is why I'm creating a table with the invisible columns. So imagine you are preparing an upgrade of your application. You are starting for the database, but your application is not prepared because your application has something like select star or insert into without the column, just values. So you can just create a column, add the column invisible, and then turn on visible when your application is prepared. Oops, sorry. So just create a new table here. Column 3 is invisible. It's not here. Let me insert. So if I do a select star, my column is not here. If I do something like this, the column is here, because I'm referencing the column now. I can make it visible. And the column is now here, so it moved to the end. So we'll have column 1, 2, 3, 1, 2, 4, and at the end 3. So why The column is at the end. On 12C we have two columns on this table, syscall dollar. I have the order of the table. I have the order of the creation of the table. SQL text expansion. This is a new function on the BMS utility. I can pass my SQL here, and let me show you what it brings. So this SQL star becomes a SQL with all the columns. And it's really useful when I have a view, because I don't have to open the view and see the code of the view. It opens the view for me and brings me all the code, including the code of the view. On 11G, if you try to create varchar more than 4,000, we have this problem. On 12C, I can have 32K. How can I do this? Just change this database parameter and run this script. And now I can create table with 32,767 characters on varchar 2. Multiple index on the same set of columns. On 212C, if you try to create an index on the same column, I got this message because the column is already indexed. On 12C, I can create more than one index on the same column. But the question is why? Why I want to create the same index on the same column? Because I will have two duplicate index. And the answer is I can test like a unique index versus non-unique, B3 versus bitmap, or partition strategies. I can try to create a local partition index or a global partition index. So I'm creating now one index unique on this column, and I will create a new one on the same column, but non-unique. If I try to create in this way, I got this error. This is because I can have only one index visible. Invisible. Now it's created. So I have this two index on the same column, one visible and one invisible. I can create a B3 index on the column 2 and a bitmap on the same column, invisible. And let me show you something. In this case, I have table access full, but I can start to use my new index to see if the invisible index will be used. I just have to set this session parameter to true. And now the optimizer start to see my invisible index. So it's really good when I have to check if a bitmap index is better than a bit3 or a unique is better than a non-unique index. Read any table, system privilege. This is a new privilege. We used to have select and select any table. So what's the difference? If I have select or select any table privilege, I can lock the row. So I'm able to lock tables or do a select for update. Grant select to user. I can lock this table. With read, I'm not able to lock. I just can see. So it's much better. Because happened to me a lot of times. The developer are doing a lot of updates, or not updates, are doing a lot of select for updates and go out to launch and forgot to do a commit or rollback, and the row is still blocked for a long time. Statistics during loads, for book loads and direct path insert, the Oracle database will automatically collect the statistics for you. So I'm creating a new table, 1000 rows. I can check, and I have statistics for this table just after the create table. I don't have to create the table and collect statistics anymore. There is an extra step here, optimizer statistics getting after the create table. Partial index. Now I can create a table and disable the index for one partition. So imagine that you have the historic data on your database, and you will not query this data very often. So you can disable this index for historic data and save some storage space. SQL Loader Express. We have SQL Loader until 12c, and Oracle creates this new mode. It's the same tool, but it's a new mode called Express. So you don't have to create your control file. It's the hard part of using the SQL Loader is create the control file. Let me show you how it works. So I'm creating a new table, empty table, with 2 rows. So I have a file here with the name, the same name of my table, my new table. It's emp test. And the file is emp test with 2 columns. So I just have to use SQL Loader, username and password, and my table name. and the Oracle will do all the work for me and create the control file and import the file. So I have now 9 records in this table. In 211G, if you try to truncate a table, and this table has some childs, you got this problem, because you have to truncate the child and then truncate the parent. On 12C, you can add this keyword, cascade, and then you trunc everything. So I have one table here, the parent table with the primary key, child table, reference to this primary key. Two records. So if I try to truncate the table, I got the same error, because this table 1 has childs on table 2. If I add the keyword cascade, the Oracle will truncate for you the table 1 and 2. No more records. No more records in these two tables. Limit the PGA. On 11G, we have the PGA aggregated target, but it's not the hard limit. The PGA aggregated target is the limit for each session. So if I have PGA aggregated target set to like 2 giga, each session can use 2 giga. On 12C, I have the new aggregated limit, and if this value is 2 giga, all my database can use only 2 giga of the PGA. If a session try to use more than 2 giga, the session will got an error and we will abort. Full database caching. Nowadays we have hardware with a lot of memory, so sometimes we have more memory than the database size. So you can enable this full database caching, and all your database will be on your SGA. So it's not in memory, it's SGA memory, buffer cache. So your buffer will not be aged out of your cache. So you don't have to do I/O anymore. Armon 12C, now you can recover just one table. This is the common recover table, table name, and it's a point in time recover. I can set one time to recover my table, just one table. Before 12C, we can recover just table space or entire database. In database archiving, it's like a status for your record, so the row can be visible or not. When you create the table, add this keyword, and Oracle will create this new invisible column or archive state. The default value is 0. If the default value is 0, the record is visible. I can update this state to 1, and now the record is no more visible. 0, when it's 1, it's not more here. To see this record again, I can set this parameter to all, and Oracle will bring the record again. Heatmap, also new in 12c. Change this parameter to on, and the database will start to track your database usage. So for each partition of the table, I have a status of the usage. I can create ADO policies like change my table space. If I have low access of these blocks in the last 30 days, please compress my records. And Oracle will automatically do it for you. You don't have to control the usage of your database to compress records. Or I can do something like this, alter my table. After 19 days of no modification, please compress this record. DDL logging, it's a new parameter. I can set to true. Every time I do a DDL statement, the Oracle will track all the information for me, like the username, the host, date. So I can see every DDL statement on my database. Arman, before 12c, I have to use the keyword SQL and the command here. On 12c, I don't need this keyword anymore. I can just use the SQL here. Session private statistics. For global temporary tables, until 11G, the statistics are common for all the sessions. On 12C, I can change this behavior, global, from entire database to session, or I can set here, just for one table. Let me show the difference here. Where is it? I think I don't have. Unfortunately, I don't have it anymore. Let me see if I can find. I found it. So I'm creating a new global temporary table here. I'm setting the preference for this table to session. I'm now creating 10 records and getting the stats. So I have 10 records in this session. So I change to shared for this table in this session. I have 1,000 rows in this session. And this other session, I have only 10. This statistic is valid, this 10 is valid only for this session. In all the other sessions that I open, we will see 1,000. So if I open a new one here, it's 1,000 for this. Temporary undo. We use to create global temporary tables to generate less less redo. Now you have this new parameter, temp undo enable. I can set to true, and I can show you the difference on the redo size generation. Let me copy this here. So I'm setting to false in this session. I will insert 1 million records. You can take a look here, redo size. Now let's enable the parameter. Look the difference. The same amount of records, 1 million, is just 4,000. And here it's 200,000. So just setting one parameter. Identity columns. The people from SQL Server used to say that Oracle don't have the auto-incremental column on 12c. Oracle implemented. This is the new syntax when you create a column, generated always, or generated by default. When you do an insert on the database, Oracle will generate the value for this column for you. You don't have to create the trigger and then create and put the select from sequence inside the trigger to have an incremental here. SQL query rows and offset. Here. So I'm now creating just a simple table with the ID, name, and salary. Before 12c, we have to use this syntax, order by here, inside and outside the raw num, to get the top 5 salaries. On 12c, I have this new syntax. Fetch first 5 rows, the order by is here, the same result. Or I can say something like bring me the first 30% of the columns of my table. Or even bring me the next 2 before the first 2. I got the records 3 and 4 because I skipped the 1 and 2. Or I can do this. Skip the first 4 and bring me the next 2. The same. PL SQL from SQL. If you are working a customer and you don't have access to create objects in the database, and you have to use like a procedure or function on your SQL, you can use this new syntax with your function here and use just in your SQL. So you don't have to create the function or the procedure on the database. You can use directly here. Session level sequence. You can, on 12c, you can add this keyword session. And every time you log into the database, the session, the value of the sequence will be 1. Let me show you how it works. Here. So I'm creating a new sequence here, keyword session. So in my session, the last value is 6. When I open a new session, it starts from 1 again. So it's useful when you are using like a sequence for a global temporary table to generate an IG, for example. No. Just keep something. We have 2 minutes. If you have questions. No questions? Let me show you this SQL. Do you know this tool? SQL. This tool is created by the same guys of the SQL developer team. You can go to the SQL developer download page, go to the bottom, and download this tool. To connect it to the database, SQL, user, password, host name, and service name. This is just a easy connection. Help to see the list of the comments. So to see my tables, I just type tables. I don't have to query my user tables. If I need some information about my table, just type info and table name. It's much better than Desk because it brings like index constraints and everything. Less analyzed, number of rows. So if setas source destination, it creates the script for me to extract like a DDL and table name. So I don't have to use the DBMS metadata. I can disable these attributes. Now I don't have the table space information. Another thing useful, I have formats like CSV format, or I have XML, or I can use hints, JSON format. I can have colors in my scripts. It's useful to create something like this. I can see my table space information. Green is okay, yellow warning, and head is an error. So if you want to try, this is a free tool. Just go to the SQL Developer download page, download and try. If you don't have questions, thank you.
Okay. Thank you so much for inviting me. I apologize for not speaking Spanish. I cannot, and I will learn, but the good thing is that both my children speak fluent Spanish. My daughter speaks Arabic. Just proof that our children are much better than us. So I apologize again. But what I'm about to present is more of a story. It's got technical information. It's a story for geeks, for nerds like us. But still, it's a story. So I want to talk a little bit about troubleshooting. In some ways, it is an art, maybe a black art, but there is a method. There's very much of a method. I use the word, whoa, did that just come up? I don't know, that's not on my screen. Somebody? Better? Oh, there you go. Okay. Still something going on there. It was good before. Let me know when you're done. Just take your time. Okay. Where was I? I was talking about the use of the word forensics. Forensics is investigation, like crime scenes. You might be familiar with some television shows called Crime Scene Investigation, CSI. All right? Now, those television shows have impossibly good-looking police officers solving crimes in mere minutes, hacking into networks and just doing amazing things all in the course of 1 hour. I can't promise you anything like that over the next 45 minutes. But at least, again, I'll tell you a story. So, a little bit about me. Far too much time spent on a keyboard as an Oracle DBA, and before that, a developer. In the 1980s, I was a C programmer. In fact, it was so bad, I would dream in C when I slept. Not good. Not good. Scary. At any rate, co-authored several books on Oracle data warehousing, SQL, and performance tuning. I'm also a board member of my Oracle user group in Colorado, the Rocky Mountain Oracle user group. We're very active, and I've been with them for about 20 years now, but I've just recently announced my 2-year retirement. I'm giving them 2 years to find someone else. Have been an Oracle ACE for a few years, and ACE director just over a few years as well, and a member of Oaktable for a few years. So a lot going on. But I found out one more thing, one more credential that I can offer, and that is yesterday, I was in Buenos Aires yesterday, and I introduced myself, and I just said, hi, my name is Tim, and he goes, he looks at my badge, he says, Tim Gorman. He goes, DBA Kevlar, Kellen Gorman, that's my wife. She's much more well-known than I am and much more talented, keeps a better blog, she has social media ratings, she's all over the place. But that's my other credential. We're married. So, enough of that. What I wanted to talk about is troubleshooting by example, okay? Errors don't usually always leave behind enough evidence that we can see. Or if it does leave evidence behind in log files or trace files or core dump files, they're scattered. Very difficult to find, very difficult to access. You, as an Oracle DBA, may have full access or good access throughout a database server. Performance problems aren't errors, but also with performance problems, there's no evidence left behind in log files at all whatsoever. So we need better tools to gather information. Trace files are probably perfect for both uses, for both performance tuning and troubleshooting problems. Oracle tracing, SQL tracing is almost a perfect tool for that, but you have to have the foresight to enable tracing first. You can't just leave tracing on all the time. So it is a great tool, but it doesn't help if you don't think about it first, okay? So always-on diagnostic features that Oracle introduced about 10 years ago in Oracle 10G provide a lot of this material for investigation, okay? In a lot of ways, they act as trace files stored in the database. They're capturing information from the database, storing it in the database. Now we can use SQL to find it, report on it, etc. So troubleshooting requires patience and discipline and optimism. Because when you're troubleshooting, you don't know if you're going to get to the end. You don't know if you're going to be successful. It's very stressful that way. But when you do successfully find out what the problem is, it's a wonderful thing. The discipline part, I will say, is that when troubleshooting or when doing any kind of investigating, stay away from Google. That's the discipline. Because Google, I will show, Google will lead you wrong. Okay, so I present 2 case studies of problems that presented very similar, but the resolution wasn't. So Informatica, right? The situation is I was working with a data warehouse in a large telecommunications company. The data warehouse today, I think, is half a petabyte in size. But a few years ago, it was no more than, say, 200 terabytes. Most of it was compressed. So it could have been a much larger database. But it was big enough. And the reason it was so big is that it was pulling in telecommunications switch data, roughly 2 to 4 gigabytes every hour, 168 hours a week, etc., 52 weeks a year. So very busy database. ETL is a very important part of this data warehouse. So here, Monday morning, I come to work, and there are messages that over the weekend, there were failures. Always happens on the weekend, doesn't it? I'm just glad they didn't call me. But Monday morning, I have all these reports, these emails, help, 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 errors in Informatica. So the first thing I do is I go to Oracle, I went to Google. But then I went to my Oracle support when I saw that there was nothing but garbage out on Google, stuff that I couldn't rely on. So I went to Oracle support and took the error message, name and text, plugged it in, came up with a good hit right away. That's the beauty of Oracle support. This note indicated that the error message, which we were getting in Informatica, the text of the error message said, connection lost contact. What's that mean, But at least the Informatica people were kind enough to give me the actual number, the Oracle number, or a -3135. So I looked up based on that. And the note in MetaLink, the first one that came up, describes it as an error message that goes back to the client side of a database connection, Informatica, right? But it also sends another error message, 3136. It emits it down to the alert log. So now I don't have to rely on people telling me that these errors are occurring. I could just look in the alert log. That's good. Oracle, thank you. That's excellent. Giving me information that I can use to investigate. Furthermore, this note goes on to explain that the error occurs because there is a point in time when you are establishing a connection to the database. There is a point in time when that connection is in limbo. It is not yet connected. Okay, so here's what happens. You're out on the network, your workstation, your application server. You send a connection request to the TNS listener. The TNS listener validates it and then spawns a foreground process to service your connection. Now, when that foreground process starts up, and then one more thing, it connects you to that foreground process, and then the TNS listener steps back out of the way. But when that foreground process is starting, there are a few things that have to be done to initialize the process, the session. So it has to query the database to populate columns within my sessions row in $session view, for instance. So those SQL statements, they're just any other SQL. They can also have problems. They can hang because they have to be parsed, executed, and fetched, just like anything else. So problems can occur. So that's a bad time, right? We have a connection to the database, but there's no user identity associated with it yet. Risky. Okay, so that's what's happening. The note also mentions some bugs and stuff, and it's too early to think about bugs. I'm only starting to investigate, so I ignore those immediately. But the note goes on to suggest that there's a couple different ways to diagnose this potential, this hang situation, okay? So the note suggests, and if you've been at DBA for any period of time, you've seen this. Support suggests take 3 system state dumps 90 seconds apart, collect the output, send it back to support. We'll look at it. Well, the problem is, like I mentioned, that it's now Monday morning. The problem occurred over the weekend. It's not happening right now. That's not going to work. The second thing the note mentions is to examine active session history for 15 minutes leading up to the time of the error. Okay, that I don't know any objections to that. What's the third one? The third one, it says, is continuously query the contents of VDAR latch holder. What? VDAR, who decided this was a latch problem? For a little bit ahead of, I understand what's happening here. The person who wrote the note solved the problem, and he was so proud of it, he had to mention it in a note. I know what that feels like. So, but it's premature. It's not a good, I don't know if the problem is latches. I'm not going to waste time querying VDAR latch holder until I get some indication that it might be latches, other than a note. So, active session history it is. That's the way I'm going to go. Have to know a little bit more about it. Oh, I pulled up another note in support. This note is entitled Troubleshooting, or 3136. Oh, that looks promising, because that's what I'm trying to do. And it mentions that there's a mechanism during the period of time when you're trying to establish a connection, there's a timeout mechanism. It's set to 60 seconds. Now, you and I know that establishing a session takes sub-second. It goes very quickly, normally. But if anything happens, it'll time out by default in 60 seconds, okay? So, as it turns out, this is the note that is propagated all over the internet. If you were to query the keywords on Google, Oracle, or 3135, or 3136, you'll see all kinds of notes mentioning this timeout parameter. Now let's think about it. Is that valid? If I have a problem, if I have a process that normally executes sub-second, and it's timing out after 60 seconds, that's eon, that's ages. If I increase that timeout, what good would that do? It'll now time out after 120 seconds, 180 seconds. Who would ever do that? Well, turns out I did. Or somebody in my shop did. We had it set to 300, right? So we were getting this error, 5 minutes of waiting for a connection to be established. So should I increase that timeout to 10 minutes? Don't think so. Obviously, increasing the length of the timeout has no impact, doesn't work, doesn't do anything. And if you increase a timeout, all you do is convert a failure into a performance problem. It takes longer to get the error now. It's performance tuning. So, understanding that the error is also sending messages to the alert log, I look at my alert log. Now, again, I'm on a rack environment, 2 nodes. This is a big database. These are 2 big servers. They're Sun M9000s. Oh, they're powerful. They're nice. Great boxes. But the interesting thing is that the way we wrote the applications against this data warehouse, against this rack cluster, is that in a few cases we did some stupid JDBC connections that only connect to instance number 1. They don't use TNS. They don't know how to use the new JDBC syntax to load balance, right? So as a result, in our rack cluster, instance number 1 is something like 4, 5, 6 times busier than node number 2. Node number 2 is almost like a warm standby. But that's where the error messages are. I'm not getting the error messages in the far busier node. I'm getting them in node number 2 only. That's interesting. But the important thing is that I'm getting the point in time, also recorded in the alert log. I'm getting the point in time. So now I can go and look into VDOLR active session history. So not for 15 minutes beforehand, but for 30 seconds before the error occurs, and see what's happening, see what's evidence there is as we lead up to this point in time where we get the error. So that's what I'm going to do. I've got my point in time. I'm going to look 30 seconds ahead, 5 seconds afterwards, and query VDOLR active session history. Just as if I was looking in a trace file and I locate a point in time that an error occurred and I want to see what's in it. So first, a little bit of information about active session history. Active session history came about also in, I believe, in Oracle 10G. It's a part of AWR, Automatic Workload Repository. But this view, these two views, active session history, are different from everything else in AWR because it's session level information. In other words, we're sampling real-time data from VDOLR session, and we're storing that. It's very fine-grained, very granular information. Everything else in AWR is aggregated to the instance level, high-level information. So what's in AWR is excellent in the rest of AWR. What's in the rest of AWR is excellent for finding big-level trends. But because the data is aggregated, sometimes up to the hourly level, every hour, everything is averaged or summarized or whatever, it's terrible for finding little problems, like spikes that occurred over the course of a second or two, or even 5 minutes. It's not good for that. Those things are averaged and aggregated out. So active session history is different. It provides you with that very fine-grained information. It's not necessarily a great source of information for tuning, but it could be, because you can aggregate it. We're using SQL. We can do aggregated queries against this fine-grained information. But again, active session history is a remarkable bit of information to have for investigations. Very, very, very complete. So again, why is it valuable? Not only is it very granular, down to the second in some cases, but also it contains information that just doesn't show up elsewhere. Identity, user identity. Everywhere else in the AWR, user identity is aggregated away. All we're keeping are the numbers. We're throwing away who ran the SQL statement, who did this, who did that. Not in ASH. We have that. That's part of the sample. We also have, I'll show you what we have later on. So again, think of session level data as almost like a trace, almost like a log, but it's inside the database where it's there ready to be queried. Okay, it's implemented, ASH is implemented inside the Oracle instance in a two-step process. Because we're sampling so rapidly from a real-time view like VDOLR session, which changes all the time, because we're sampling every second, we have to have a high-speed mechanism for capturing that information from VDOLR session, and then a high-speed place to store it, at least temporarily. So ASH is implemented as a circular buffer inside the SGA, a fixed-size buffer, but it's organized like a loop. And as fast as we capture the information from VDOLR session, we throw it into this buffer, and we just keep appending to it. Now, it's circular. What's going to happen eventually? We're going to overwrite information. So before that happens, we have one process that's scraping, capturing data from VDOLR session, and throwing it into the ASH buffers. We have another process that's coming along before we eat our tail, circular, before we lose data, we flush the information down to permanent tables. Okay? So we've got two views in active session history. The memory-based one, $, active session history, and then the one that's based on disk in storage, DBA hist active ses history. They ran out of characters. Oracle has a limit of 30 characters, right? So they named it a little bit different. So all these parameters that I show here govern this activity. The interval of 1 second for the memory-based view. You could configure that, don't do it, but you can change it if you want, if you really feel like it. When that memory buffer gets 2/3 full, 66% full, and again, that's configurable, that's when something is triggered to flush from memory down to disk, okay? And, one more little item. When we flush from memory to disk, we don't flush everything. There's too much data. At least they felt that there was too much data back when they designed this. So they threw in a filtering ratio that says it's set to 10. It means that 1 out of every 10 rows are captured from memory, thrown down to disk. So the granularity goes from 1 second in memory to every 10 seconds on disk. Now, in today's computing, our chips are running at the nanosecond level, right? Networks and I/O are running at the microsecond level, in milliseconds. There's a lot that can happen even in 1 second. There's even more that can happen and pass unnoticed when you're only sampling every 10 seconds. But all I can say is, it's better than nothing, We've got this information. If you're able to look recently enough to capture the information in memory, you've got the ability to see 1 second apart samples. But otherwise, using the retention of AWR, which is by default a week, and I like to set it to months, you can examine 10-second sample information going back again, a week or months or something like that. So active session history, I'm just describing here that retention is configurable, okay? So here, I'm on a production system, it's Monday morning. I have to investigate something that happened over the previous 48 hours. Unfortunately, memory got flushed. But I've got my 10-second sample information on table, so let's go there. Sorry. More about what's in active session history. Great information. Timestamp, of course, it's a time variant data. User identity, user ID, session and serial number, those are just values that Oracle assigns when a session is created. In and of themselves, they mean nothing, but they can be used for grouping. So you can tell which samples belong to the same session over time. We have program, module, and action. If you know what DBMS application info is used for, it's used for linking a SQL statement or a stored procedure call to a point in the application code. This package, DBMS application info, is used extensively throughout eBusiness Suite. Kerry Millsap led the charge on that. Kerry Millsap is a god, I think, so he led the charge on doing that. He convinced Oracle to do that back in the mid-90s. And it's yielded fantastic results for eBusiness Suite as a software package. At any rate, great information there. You get information about the SQL statement, the individual SQL ID, the SQL plan hash value, which uniquely identifies an execution plan. Even better than that, because we're sampling at least once a second, we're also getting information about where the session is within that execution plan. Think about this. What if you have an execution plan that has 750 steps in it? It's not good enough to know that you're using that one execution plan because there's 750 things to choose from that it might be at that moment in time. But that's captured. The line in the execution plan where it is that second is captured. That's great information as well. PL SQL module. In case your SQL statement that's currently executing is somewhere inside a stored procedure or a trigger or a function, the only thing we can capture here is the top level call where we entered PL SQL and the current level where we're calling the SQL statement from. There could be no additional calls in between that, or there could be 100. You could have a trigger, call a procedure, call a function, call it, you go crazy on that. So we just have the top and bottom. It's not perfect, but it's better than nothing. Parallel execution information. If you're, tracking a session, is it a serial session that's doing all its work on its own? Is it a query coordinator that does no work but tells everyone else what to do? Or is it a parallel query worker? Good to know, depending on the circumstances. If your session is being blocked by an application lock, an NQ, then Ash will capture who's blocking you. That's great information right there, isn't it? But the best information of all is the last, wait event. Wait events were a mechanism put into Oracle back in 7.3, 7.0 time frame. Okay, and think of it as, well, it's an old mechanism, but think of it as posting a gone fishing sign, right? If you run your own shop, you like to go fishing in the middle of the day, just because. When you leave your shop, you put up a sign that says gone fishing, now people know where you are, maybe. And then, when you come back, you take the sign down. Same thing with the wait interface. When an Oracle session is about to come off of CPU and make a system call, say for I/O on disk or I/O on network or anything else that would cause it to lose the CPU, become wait. What it does is it posts one of these wait events, makes the system call, and when it finishes, it comes back and unposts, and also records how much time it's spent away. Okay? So that simple mechanism, spread over, it has to be over 1,200 different events, gives us incredible detail about what's going on inside the database engine and where time is being spent, because that's what's important, especially for performance tuning. Where is time being spent? Okay. So tough to see, I apologize. The slides, I'm sure they'll be posted somewhere, but all I have here is a query against the AWR view, the one that has the 10-second samples, the one that has the long-term data. So I'm querying from that, I'm querying some columns, and I'm querying 30 seconds ahead of the occurrence of one of the errors and 5 seconds after. And I don't know what I'm looking for. I'm just fishing, just looking. I highlighted in red the things to me that look suspicious. The things that aren't highlighted are things I'm used to seeing on this particular data warehouse. Direct path read, PXDQ send blocked. That sounds complicated. It means parallel query worker blocked trying to send information back to the query coordinator. Happens all the time. Nothing unusual there. But other things like GC current request, oh, what's that? Row cache lock, that doesn't sound good. ENQ, SQ contention, what the heck? That deserves investigation. So all I do is I query from Ash, the Ash view, ASH view, and look for strange things. And then research each one of them. Okay, so the first thing, the one that to me looked the weirdest and most dangerous, was the one that had the word contention in it, the wait event that said contention. SQ contention. Well, SQ stands for sequence. The mechanism of sequences is this. Sequence objects, they're so taken for granted in Oracle. But if you work with a database that doesn't have them, it's absolute hell. Right? Here's how you generate sequence numbers for a primary key or surrogate key without sequence objects. You create a table that has one column, one row. Your process, in order to generate a sequence number, queries that one row, one column, updates it. That's it. So imagine if you will, 1,000 sessions doing that all at once. One is going to be able to modify that row. 999 are going to queue up. It's terrible. So to resolve that, long ago, I think it was in Oracle 7, maybe even Oracle 6, Oracle created the sequence object, which still uses that same mechanism. It's based on a table. The data value is stored in the table in the data dictionary, but the mechanism is shared across the entire database instance, in fact, across the entire cluster, memory bound. The instance, the first person who uses the sequence will query data up from disk, from the table, but stored in the SGA. And we manipulate it inside the SGA. And if it's a rack cluster, we share that information, right? So it's very fast. And every once in a while, we have to refresh that sequence from its base table. Great mechanism. Well, this is the wait event that's posted when we have to refresh. Great. So we've got a lot of weights on that, according to ASH. So I want to know more about this event. There are things that you can Google and get some explanation about, but within the Oracle instance, we have a view called $V event name. It gives a brief description of what those parameters, P1, P2, P3, gives a brief description of what they are. For this event, P2 is an object ID. Very cool. Object ID tells me what sequence object we're dealing with. I query DBA objects with that value, 144. It tells me it's a sequence named odd_$. Wait a minute. There's a column in $V session called odd_. Okay, do you think there's any chance that when a session is being established that we populate the contents of odd_$ with odd_$, a value from that? Could be. That's actually what happens. Great. Next wait event, row cache lock. What's that? A little bit of research. It turns out the phrase row cache is Oracle Development's name for data dictionary, or actually data dictionary cache. Don't know why they named it that, they just did. So it really ought to be called data dictionary cache lock, but they didn't. So row cache lock, when you look in VAR event name, parameter P1 indicates what part of the data dictionary cache, the cache ID. And if you query, come on, there we go. If you query $V row cache on that value, you see that it's an object called DC, dictionary cache _ sequences. Okay, so I'm getting a lot of wait events on sequences. Not just on refreshing the sequence, but also on the row cache part of sequences, right? Okay, sequences. Keep going. GC current request. Anything that starts with the phrase GC is a rack wait event. Has to do with clusters. GC stands for global cache. So really, this wait event mirrors I/O wait events, non-rack I/O wait events. This mechanism of sharing data across instances sits on top of regular I/O. So when we're waiting on I/O, we post a different event for that. But when we have to share it across an instance, we post this wait event. Like other I/O wait events, P1 is a file ID in a data file. P2 is a block within that data file. P3 is the number of blocks. You get that from $V event name. And they're all like that. All the I/O events are like that. So I look at P1 and P2 for this GC current request. By the way, a current request means I'm about to update something. I want the current version of that block. And it shows me file number one, file number one, file number one, data dictionary, right? System table space, file 1. Block 180. Wonder what's there. What's in block 180, or what structure? So I query DBA extents, look at file 1, block 180, this query, and it tells me seek $, is the name of the table. This is the table that stores the sequence values. Wow. Sequence, 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 sequence. I even know which one. I think I've got it. This is cool. This is why I love troubleshooting, you know? You're hopeful that you're going to find it, but you're stressed that you may not. But when you think you're on the trail of something, it's like euphoria. It's just ecstasy. Whoops. So let me use another one of my queries that I use to check for poorly cached sequences. I just query the DBA sequences view, and I look for cache size less than the default. The default is 20. So if somebody created a sequence with a cache less than 20, I consider that to be poorly cached. Not enough cache. And then the rest of the query just looks for sequences that are used a lot. Okay, that's basically what it means. And then I order them. And I'm sure to find that odd cess dollar sequence in here, and I don't. Odd cess dollar's not in there. Come on, everything is pointing at odd cess dollar being the problem. All the evidence, I did everything the most scientific way possible. And then I remember. This is the difficult thing about getting old. Memory. All right? I turned up a ticket from 3 months prior, a production ticket, to increase the cache size on this odd cess dollar sequence. I had gone through this exact same thought process 3 months prior, didn't remember a thing of it. It was easy, it's like muscle memory. It was burned into my brain. I went straight to but I didn't remember actually doing it. And here, odd cess, 500 it's set to. That shouldn't be a problem. So I've got all this evidence inside ASH pointing towards sequences as being the problem, but not this one. What's wrong? What could it be? Yeah. What else could it be besides sequences? So it's an investigation. I've thrown a lot of clues out here. Somebody threw up yesterday, I did this presentation yesterday, and somebody said, ITL contention in a block. You're having, sorry, I got ahead of myself. One more bit of investigation I did was I looked at the block in which every single sequence object resides. And it turns out that every single sequence, the entire table of seq dollar resides in that one block. Okay, this is a big rack cluster. They made 32K blocks. I didn't know that when I started. 32K blocks, that's 4 times bigger than the normal Oracle block size. This thing was on Solaris. So they've got the entire table inside one block. One block, entire table. Rack. What could it be? And again, now I kind of blew it a little bit. Somebody said, what about those ITLs, those transaction entries that govern who's got a row lock? And it wasn't that, because that's got its own weight events. There's specific ENQTX weight events for that. But we were seeing GC weight events. We were seeing ENQ, SQ, different weight events. One block contains the entire table. I have a rack cluster. I'm seeing GC, weight events being posted. Now here's the interesting thing. Back a few slides ago, I mentioned that one of the nodes is far busier than the other. 5 or 6 times, a lot busier. In fact, it's so bad that one time node 2 went down. It was down for 2 weeks. We didn't know about it. Nobody complained, and we weren't monitoring. Embarrassing. DBAs aren't supposed to do that. But anyway, node 1 is far busier. Far busier. Unequal workload. Rack cluster. You've heard the recommendation by any rack expert that you try to load balance. Here's one reason why. This sequence was being used by processes on both instances. But on node number 1, that instance was so busy, it was holding on to that block and wouldn't share it with node number 2. It will share it eventually. But if the activity on node 1, for any sequence, is pinning that block on node number 1, node number 2 is going to wait a long time to get that block. She's going to sit there, tap the other guy on the shoulder and say, please, excuse me. The other guy says, wait, I'm busy, hold on, Just like that. It's called starvation, and it happens when workloads are unbalanced. It happens in rack. So, whoops, did I jump? Yeah. I think I jumped too far. Anyway, so all these waits on GC buffer busy, GC block 2, I don't know what that means, GC current request, was node 2 trying to say, hey, give me that block, I need it. And again, because all the sequences were inside that block, it could be any sequence, not just odd cess dollar. that was causing that block to be held in instance number 1. So as a result, how can I fix this? Turned out to be incredibly easy. All I have to do is change the cache value on all the under-cached sequences so that they finally have, a decent amount of caching. I set them all to 100. I checked with support, make sure it's okay to do that to the ones owned by sys. They said, yeah. So I used that same query that I used before against DBA sequences to generate the SQL and ran it. No downtime. No need for a ticket. And that's worked to this day. And I thought, wow, that was fun. This was fun. I'd have been I already tore my hair out. So I'd have nothing else to tear out if I couldn't figure this out. But we figured it out. And so I made this presentation. So proud of it. Thought I was such hot stuff, right? Okay, skip forward 4 months, I think it was. I'm at another customer, new customer. They have a 2-node rack on AIX running OBI-EE, data warehouse. And the boss comes to me, and he's someone who hasn't quite got, I don't know, I'm scared of him. He's very rough and gruff, and I'm afraid he's going to fire me every day. So he comes to me and he says, hey, we're getting this error message. It's 3135. So I was like, ha, I know that one. He's like, oh, good. Can you fix it? I said, not only can I fix it, I'll tell you what it is right now. And then before I opened my mouth even further, this little light went off in the back of my head saying, shut up, shut up, shut up, shut up. Right? I said, let me go take a look and I'll come back to you in about an hour, let you know what it is. He's like, sure, you do that. So I went from being, world's expert on it, and thank God that little light went off and said, shut up. So I went back to my desk. And it was the Hyperion process, not Informatica, that was having getting the error. But here, the alert log on both nodes had the error. Not just one. And all of a sudden, that little voice in the back of my head is going, oh no, oh shit, my God. Terrible, both nodes. And then I query Ash for the events, the wait events. And I just do frequency, select event count star, order by count, descending. And it shows me none of those familiar wait events. Nothing to do with NQ sequence contention, nothing to do with row cache lot. It's all about latches. Oh no, am I in trouble? So I got to come up with something now. Okay, it's all about latches. Nothing to do with sequences, nothing to do with rack. Even though it's on a rack system. How can this be? So a little bit of research in VDAR event name shows us that one of the parameters specifies which latch. A latch is a synchronization mechanism. What this tells us, or what this can tell us, is approximately where in the code, the Oracle code, this synchronization is happening. Maybe we can figure something out from it, maybe not. I may have to ask a real expert at support or something. But I know that parameter 2 is going to tell me which latch. Whoops. And I jumped forward too far. VDAR latch name translates that from a number into a name. So I added that to the query on DBA hist active session history, and I'm getting, again, same thing, a frequency graph. 174 hits on this latch called parameter table allocation management, and then 153 hits on the shared pool latch, the one that governs the entire shared pool, where the shared SQL area is stored. The other latches, not so much. Always look for the big numbers. I always go after the big kahuna. So it turns out that parameter table allocation management latch has to do with auto SGA management. You familiar with that? Instead of having to set and fine-tune every little parameter that governs how big a component of the SGA is, instead of the DBA having to do that, starting with 10G and 11G, you can now set either SGA target or memory target to a value, which is the amount of memory you want to use, and then Oracle decides how much memory to allocate to each little structure. Darn. So all these other parameters, they still have a role. When you set SGA target or memory target, these other parameters that used to be used to set sizes still have a role. They should default to 0. They should be set to 0. But if you set them, they become a floor value for that component. In other words, auto SGA management is still allowed to adjust it bigger, but not smaller. So it becomes a floor value. So that's how it works. So now the big question is, now that I've got things pointing at auto SGA management, how can I find out if it's been extra busy? Well, there's a view called VDAR SGA Resize Ops. It's history. It's like a trace, if you will. And bingo. I correlate the information in VDAR SGA Resize Ops, and every time I get the Aura 3136 error in my alert log, I'm seeing a lot of activity here. And what's happening is that it's a condition that a very deep technical term here, I call it a pillow fight. You've got the shared pool wants more memory, so it takes it from the buffer cache. A second later, the buffer cache wants more memory, takes it back from the shared pool. Like a pillow fight, two children fighting with pillows, right? They're constantly fighting over that 100 megabytes of space. I want it, no, I want it, no, I want it, that kind of thing. That's what's happening. So the shared pool isn't very graceful about losing size. If you're trying to parse SQL statements, when the shared pool latch is being held while it's being resized, it means your parsing stops, right? Among other things. So now, what can I do? My thought was, let's dampen the thrashing. What do I mean by that? Well, right now, my two kids with the pillows, they're hitting each other every second. What if they hit each other every 30 seconds or something like that? Slow it down. Let other things happen. So to dampen the thrashing, I decided I wanted the shared pool not to get any smaller than some value, like 6 gigabytes. It's a big shared pool. But then again, are you folks familiar with OBI-EE? Oracle Business Intelligence Enterprise Edition. It generates its own SQL statements. Sometimes these SQL statements are 150K, 200K. If you printed them out, they would be 100 pages long. Nuts! It takes a long time to parse that. It takes a lot of space to parse that. Big shared pool is crucial for performance in OBI-EE. Here's something else. Think about it from the big picture. I'm a user. I submit a report to OBI-EE. 200 kilobyte SQL statement hits the shared pool. So now the shared pool needs more space. Got it. Then it starts running. I've determined the execution plan. Shared pool doesn't need as much space anymore, but the buffer cache needs space. There's my pillow fight. Now multiply that by 50 users, each one of them submitting a SQL statement, then needing to run it. That's where my pillow fight comes from. Thank you. So, dampen the thrashing. I could do another presentation on why I chose that particular value, but suffice to say, it was at the 85th percentile of observed sizes. Basically, all the sizes that the shared pool gets set to are recorded with an AWR. So I looked at that. And I set it to not the max, but somewhere below the max. Felt good. But it worked. Okay, so I was a few hours late getting back to the boss, but he was in meetings anyway. But I was able to say, yeah, I know what it is. And I just didn't have to say it's not what I thought it was. But that's it. They both had the exact same symptoms, didn't they? 2-node rack, data warehousing application. Okay, AIX Solaris, but still similar. But they have entirely different causes. So in future, how do you go about dealing with that? That kind of mystery, that kind of, how do you approach your job with confidence? Knowing that stuff like that can happen. And the way that I would say that you do it is the data's in there. It's in Ash. It's in other strange little views like VDAR, SGA, resize ops and stuff. It's in there. Thank goodness, So you can actually follow the facts to reach a conclusion you never even dreamed of, right? Or two. I'll bet there's a third cause of this kind of problem sitting out there, haven't encountered it yet. But do I feel confident that I can find it? Pretty much. Maybe. Could be something that even Ash can't trace. But anyway, that's the basic idea. We've got great diagnostic tools. Sometimes they're known as performance tuning tools, but they're also able to be used for troubleshooting. And understand what's in there, and just have fun, and be confident. So that's about all I have for now. And thank you so much. Thank you for your attention, and enjoy the conference. Thank you. I'll take questions if there's, I don't know, all you have is lunch here. I don't mean to be the person standing between you and lunch, but if you have any questions, I could either take them out here or take them right now. It depends on whether someone wants to kick me off. Also email and Twitter. So thank you so much. Thank you. Oh, and thank you to Cameron, who saved me twice today. I just arrived at the airport this morning, and I had a 10 o'clock session. Cameron offered to take my 10 o'clock session. I plugged my laptop in here. Resolution is terrible. Cameron donated his laptop, so I don't know what else to ask him. Do you have any money?
Oh, yeah.
I tried, yeah.
Any some kind of license for query the
Yes, license, yes, always. Enterprise Edition. ASH is part of the diagnostic pack, but there's a package on the internet in Git called SASH, Simulated ASH. Our good friend Kyle Haley, who has produced so many great packages and posted them up for everybody to use for free, he wrote that one. So if you are unable to use AWR, you're unable to use ASH. So if you're using StatsPack, use SASH alongside StatsPack. Yeah. Yeah, thank you. Good point. Now, I have to keep you awake after lunch. That's my job. Good. This is another story, another engagement that I have from consulting. It has to do with performance tuning. We were trying to tune the performance of an application that Oracle bought about 10 years ago called Demantra. Demantra is a business intelligence application, but it's more than that. It's used for demand planning. It does predictive analytics. It does what-if analysis. It's an interesting application, and its audience is people with C in their title, CIO, CEO, CFO, right? So we were trying to tune Demantra. We ran out of options. And we decided in the end that rather than trying to force a different kind of indexing or trying to use partitioning or trying to influence the optimizer, the only thing we really could do was just try to make it smaller because we can scan through smaller faster. So we started to explore options involving table compression, data compression. So Oracle has two kinds of table compression available. But what we ended up using was another kind. It's not a supported option for compression. So that's kind of the story behind the story. And I'll finish the story at the end of this 45 minutes or so. But along the way, I want to do a brief overview of compression. It's actually very simple in concept. All of the different compression algorithms are relatively simple. I mean, there's a lot of math behind them, but the basic idea is simple. Then I wanted to go over a little bit about the internals of how Oracle stores data. So hopefully I won't take too much time over that. I've been known to spend 90 minutes on these slides. I'll try and do them faster. And then we'll come back to the story. Why we couldn't use, which ought to be obvious at that point, why we couldn't use the two supported forms of Oracle compression, and why instead we had to use a much older and different kind of compression. So, jump right into it. It's not really a story about table compression, but along the way, I have to walk through the mechanism of compression. It was a story about a solution to a specific problem. It was a lot of fun coming to it, arriving at this solution. And it's not a permanent solution. Simply shrinking the volume that all the tables in the application take up is not a permanent solution, because they'll grow. And sooner or later, we'll be back in the same situation. But it helped. This solution was arrived at kind of as Exadata was becoming an option, but it wasn't an option back then. So it might be a better option for the problems that Demantra is facing now, better than this solution. But anyway, it makes an interesting story. So, whoops. Data compression in general, the first academic papers on it were written in the 1970s. Two guys, Lempo and Ziv. Now we know them as LZ. We see the LZ letters used in the names of the different algorithms all over the place. But the simplified algorithm is remarkable. It's just this. Let's say you have, basically you have a data set that you just want it to take up less space. Their algorithm, their original algorithm, is just this, that you break it up into chunks, 10 bits, 8 bits, 20 bits, who knows. You break it up into so many chunks. That implies, well, let's say it's a 10-bit chunk. That implies that there is a maximum of 2 to the 10th variations for what bits could be inside that 10-bit chunk. So you can now take that 10-bit chunk and reference it with a smaller integer, an index, and replace the data with that chunk. I'm sorry, with that index, sorry. Replace the data with, so let's say I have an image. It's a photograph of a, just outdoors somewhere. You notice that a great deal of that photograph is the same shade, the same color. If we break that photograph up, the image of it, into 10-bit chunks, then we have a maximum of 1,024 different possible images. So we keep that array of 1,024, and what we can do is replace the actual data with the reference, the index, and that reduces the size of the data, the payload that we're storing. So it's extremely simple. And from that basic algorithm, there are a lot of other algorithms that are used today. Some of them apply one algorithm over another, like bzip2. That algorithm makes multiple passes for compression. So that's, in brief, what's been happening. Now, I'm having trouble here. Good. Oracle, inside the database, started employing compression gradually. The first thing that was employed was index compression, and that was extremely simple-minded. Index compression was just the idea that if you had a multi-column index and you were able to sort those data values for those multiple columns that were in the index, if you were able to sort the index entries by the least frequently occurring first and the most frequently occurring later, basically you would have repeated values in the leading columns. Why store them at all? If you're repeating, let's say you have three columns, value 111, 112, 113, 114, 121, etc. Why would you store those repeated ones in the leading edge? You don't have to. You could just leave them blank. and let it be assumed until the data value changes, then you can store the changed value. That's essentially how index compression works. It isn't very useful because not all indexes are sorted in that manner, but it's available, and it's been there since Oracle 8i. In Oracle 9i, Oracle employed something very similar to the original lump-ziv algorithm to come up with its original implementation of table compression, and we'll talk about that some more. Then in 10G, not much happened. We started compressing RMAN backup sets. That was it. That's nothing to do with table compression. But in 11G, everything broke loose. All of a sudden, Oracle was employing compression for lobs, for data pump, for data guard, everything that could be compressed, everything that was taking up time and space moving around was being compressed. Later on in 11G, they came up with hybrid columnar compression for use with Exadata, ZFS, and all the pillar, the different kinds of Oracle storage. And they enhanced table compression. So I'm going to talk about that. But that comes out to two different forms of table compression. The basic and OLTP, that's one really, because they're just two flavors of the same algorithm. And then the hybrid columnar compression. Those are the two forms of supported compression. And I mentioned in the title of this presentation that there's a third. I'll get to it. So these are what we're going to talk about. I think I jumped ahead too far again. Yeah, so the syntax is very simple. It's changed over time. I know you can barely see the screen because I can barely see it. It's rather blurry. But the name of the operations changed over time. It started off with create table compress in Oracle 9i. And then when they made some changes in Oracle 11G Release 1, they added the compress for OLTP, compress for transaction processing option. And to differentiate it from the original form, they call that for direct load operations, which you got to be wondering, what is that supposed to mean? It actually means a lot if you understand what a direct path load is, but it needed the explanation. So in 11GR2, they renamed all the commands one more time. And so now we have create table compress basic, compress for OLTP, and then we have the HCC compression levels, which is compress for query, low and high, compress for archive, low and high. So we'll talk more about those as time goes on. But just be aware that the names have changed over the versions. It's a little bit confusing, but in the end, this is what they've settled on. And they won't change them anymore, I hope. God, it keeps jumping forward twice. So, starting with compress basic. Very similar in concept to lump-ziv. Here, all that we're doing is every time we store rows in a block, in a data block, every time a column, any column, say it's numeric or character string or date, anytime a column has the exact same value, what we do then is we take the value out of line from that row, store it somewhere else in the block, and replace that data value with an index, just like what lump-ziv did. So I'll have more detail about this. I'll do block dumps and everything and show you. But that's it. So the occurrence of the value of 100, if there's more than one row or more than one column, anywhere a numeric value of 100 appears, what Oracle is going to do is going to take it out of line, store it somewhere else within the block in another array. It's called actually the symbol table. And then what's going to be left inside the row is just an index to that data value inside the symbol table. That's it. Very, very simple, but it's actually a little bit more powerful than that, and I'll show you that. It's got some restrictions and limitations, like tables that have more than 255 columns can't use this. Index organized tables, table clusters can't use it, and you also can't do alter table drop column when your table is compressed. These all have to do with the way that data is stored inside blocks. These are why these restrictions exist. And I'll show you why the 255 column restriction exists, for instance. Okay. One other weird thing, if you will, about basic, compressed basic, is that it only works with direct path loads. And you're wondering, what is that? You've heard of the command insert with the hint append? That's a direct path load. It's a fast bulk load. In other words, compress basic doesn't work with all operations. It doesn't work with a insert that's not append. It doesn't work with update, or well, certainly doesn't work with delete. Why would you compress deleted data? But anyway, that's another characteristic of it. It's not available in standard edition either, unfortunately. Now, compress for all TP came along several years later. It uses the same basic Lempel-Ziv algorithm with replacing data values in a symbol table, but the difference is that it is now finally available for all operations. So compress basic is only available when you're inserting in bulk. That's it. Compress for all TP is available regardless of what DML command you're using. Insert, update, no delete. Again, insert, update. Conventional or direct path. It's got some of the same restrictions and limitations as compress basic, but it's that. So the type of application that you're going to use the different kinds of compression, the type of application is different. Compress basic, the only time you really use bulk loads is for what type of application? Data warehouses. Really? Data warehouses, when you're throwing in lots of data into a database. Compress for all TP is suitable for pretty much any type of application. And in fact, it's even used in eBusiness Suite or PeopleSoft at times. So the whole idea here is that with compression, table data takes up less space. You save money on storage, but more importantly, you save on performance. Smaller data is queried faster, okay? So I'm going to get into more detail about this. This is my pitiful illustration of an Oracle block. You can see something better and similar to it, and it doesn't help that it's so blurry. But the idea here is that the top of the block is a header. It's about 112 bytes long. And regardless of how big this block is, if it's 512 bytes, 2K, 4K, 8K, the header is always that same size. So the bigger the block, the better. But 8K is the standard Oracle block size. And then there's a little piece at the tail that's part of the header, if you will. It's used for checking for block corruption, long story short. But between those 2 points, the header, 112 bytes, 4 bytes at the tail, in between we have two data structures, starting at either end and growing inward. Because with Oracle, free space is always kept coalesced in the center of the block. So the data structure that starts from the header and grows inward, they're called the interested transaction list. These are the entries that represent row locks in Oracle. They store all the information for locking rows. That's why there's no $view to see row locks, because the information is not centralized. It's in every single database block all throughout the database. That's right there. It grows inward from the beginning of the block below the header. The purple section is row data. It grows from the tail of the block backwards into the block. So again, free space is always coalesced. So that in BASIC is how data is stored. Whoops. I've got this eye chart here. Sorry about that. Again, it's a blurry eye chart, even worse. But this is, I pulled this off the internet, and I've seen it in various bits of documentation. It basically describes what the header, the row header, block header looks like, what the fields are, etc. So there are online links and references so you can explore further. Visually, what a row looks like is somewhat, how did I get here? Hold on, I think I skipped another slide. Yeah, no, okay, so this was all about row format, not block format, sorry. So just about every data structure in Oracle consists of a header and a payload. And sometimes recursively, I'll have a header and then the payload, and then the payload has headers and payloads. So we're going to see that. And this is it in detail, but this is what it looks like in terms of a picture. Each row has a header from 3 to 5 fields including a bit flag, a bunch of bits for locking, and a column count, number of columns stored in the row. Even though a table may have 100 columns in it, we may not be storing 100 columns worth. We'll get to that. So the number of columns that are stored in the row. Then for each column, we have a header, just a length, and a payload, which is the data. So it's recursive, header, payload, header, So we have column number 1 here, column number 2 here. Column 3 is a long one. Column 4. Column 5 just consists of a length because it's null. Oracle stores a flag byte, hex FF, hex digital 225, 55, to represent a null value if that null value isn't trailing. What do I mean by that? Maybe this table, it shows 7 columns here. Maybe this table is defined with 100 columns, but only 7 are showing here. And 6 of those 7 are not null. One of them is null, column 5. So the non-trailing null values have a single byte to hold its place, to indicate that it's null. But the other 93 columns in this table are not even stored. Brilliant. Why would we store something? Why would we store 93 single bytes showing hex FF like that? There's no reason for it. Oracle saves space by not storing trailing null columns. There's something we can do with that there. I'm going to skip forward fast through this because, A, nobody uses clusters. Has anybody ever used table clusters? I did, but just for play. Actually, it's in the data dictionary. There are several table clusters in the data dictionary, but who cares? At any rate, clustered tables are, think of them as physically pre-joined tables. That is, there is data from more than one table in each block. They're physically pre-joined. That violates the rules of relational databases, by the way. Cod and date, they're yelling at Oracle saying you're terrible for this. And maybe that's why Oracle hasn't done anything with table clusters. But I just wanted to show that it's possible to have data from more than one table inside each database block. And I show a block dump here, just to prove it. I don't know if you've ever dumped Oracle blocks, but there's a command called alter system dump. And here I'm showing data from one of the table. Whoa, that didn't work. There we go. I'm not going to try that again. I show data from one table and one row within that table. Here's the column value, the length and the payload and such. And here's a different table, again, with 3 columns in it, column 0, 1, 2. I don't want to get too far into this, but if you are interested in dumping data like this out of an Oracle data file, this is undocumented. I found it by doing the command strings-a against the Oracle executable. I'm not sure if it shows anymore because I think they stripped it out, but that's how I found this particular syntax. Alter system dump data file. You can also dump control files and redo log files and such. But basically you dump it by specifying a data file number or name and then specifying what single block or range of blocks. And the dump goes to a trace file. So that's how you can see what's inside these blocks. Just there in case you're interested in exploring. Okay, another concept to mention besides table clusters is row chaining. When Oracle was written years and years ago, they didn't anticipate that tables would have more than 255 columns. Later on, we broke right through that barrier, right? We've got lots of tables with thousands of columns in them. But what they did was they adapted their table structure so that instead of, expanding their table structure to include more than 255 columns, basically what it is that they have that column count. You saw in the row header it said column count. It was 1 byte long. 2 to the 8th is 255. They did not want to change that column count length. It's a Y2K problem all over again. So what they ended up doing was doing transparent chaining of row pieces within a block. That's what happens. So there's 3 kinds of row chaining that Oracle does. If you have a row that is too wide to fit inside a database block, Oracle will lay it across the blocks. That's called chaining. There's another form of row chaining that I just mentioned. When a table has more than 255 columns, it'll chain together multiple row pieces, and you'll never see that. It's all internal, unless you dump. The third form is when you have a block that's full, and you modify one of those columns to make it bigger. Oracle can't fail on that. Can you imagine what would happen to your code if you tried to update a row and you didn't know where it was stored or that the block in which it was stored was full, and Oracle wouldn't let you complete the command because the block is full? So instead what Oracle does is it performs what is called row migration. You update that row and it can't fit inside the block. What it does is it leaves behind that row header that I showed on the page. It leaves that behind, but it moves the row to another block that will fit. So there's all these different kinds of row chaining. And I just mentioned that because we're going to see it again. It's important to the concepts that I'm talking about with compression. And that's another block dump involving row chaining. Again, I'm going to move forward fast over it because I don't have much time. I think this is the last concept, talking about direct path loads. Direct path loads, bulk loads. The reason why they're useful is that they allow you to load a lot of data very quickly because they bypass everything in Oracle. Oracle is a very complex mechanism. When you're inserting data, updating data, selecting data, it's keeping track of everything to make sure that you see the correct version and image of each row and each block and each column. Very complex. This is different. When you're going to do bulk loads of a lot of billions of rows of data using this mechanism called direct path, you bypass all of that, and it basically becomes straight I/O from your program right down to the Oracle data files. That's basically what happens here. And that, remember, direct path loads is how basic compression works. So I'm going to skip forward pretty fast through this, but the direct path operation is something that started back in the early 90s when Oracle was competing with IBM for space on mainframes on MVS. It started with that. But then it expanded throughout the entire product. It's everywhere now. When you move partitions, alter table move partition, that's a direct path operation. When you create indexes, direct path operation. There's so many things that are direct path operations now that just bypass all the complexity. So that's the thing about direct path loads. They load data outside of managed space. They don't think of direct path loads as being the crazy uncle at the family reunion. You know, he's good to have around for some things at times, but you don't want to spend too much time with him, okay? That's true here as well. Direct path loads, they're useful in certain situations, mostly having to do with data warehousing. But they are absolutely not useful in a situation where you're loading into a busy transactional system like eBusiness Suite or PeopleSoft or anything. There's almost no use for them there. And so it's fast because it bypasses everything. Here I have some illustrations about how conventional path, when you just use all the complex mechanisms that Oracle uses for managing data, conventional path, when you use that, here's what happens more or less when you load data into a table. When you start inserting, there's this thing called a high watermark that points at the bottom of the table. High watermark is like when you're filling a bathtub. When you fill a bathtub, you can see where the water, as far as it got, that's the high watermark. And then when you drain the bathtub, that line is still there. That's what they're trying to portray here. So the high watermark, when the table is just created, is at 0. But as rows start to become inserted here in the middle, then the high watermark is bumped up by 5 blocks at a time. And when that fills up, it keeps bumping up higher, like that. So when you allocate space for a table, a lot of it is unused. But as the high watermark moves upwards, that's known as managed space. That's where Oracle is managing the space using all those complex mechanisms. Direct path loads use that unmanaged space outside. So direct path loads either occur here, or for parallel direct path loads, we actually allocate temporary segments and load into those. And again, they're outside of managed space as well. So the whole concept of direct path loads, does anybody make use of them? Does anybody manage a data warehouse as a DBA? Yeah, a few of you. So you've used direct path loads. This is some of what goes on. And you understand, too, the restrictions for using direct path load. If you perform a direct path load against a table that other people are trying to modify or even query, they can't do it. Direct path operation kicks them out, right? Anyway, so direct path loads are useful, but that because compressed basic is dependent on using direct path loads, you know that compressed basic was only of limited use itself. So now, we're back to compression, having described some of these other concepts. So compressed basic is a symbol table that stores all the distinct data values individually, just one copy, and then it replaces where those data values were in the row, it replaces those with an index value, which is much shorter. So I'm going to jump straight to here. Another block dump, sorry about that, but hopefully this illustrates it a little bit better. What I'm showing here is a single row within a table, row 0. This first field, TL, stands for total length, 14 bytes, TL. And actually those 14 bytes are shown down at below, the actual bytes themselves, in this field called binary dump. Again, it's so blurry, I'm sure you can't see it. But way over here, you can see this field called CC for column count. 13 columns in this table, in this row, in 14 bytes. Now, what I've already told you about how rows are formatted with a header and with payloads, and how columns also have headers and payloads, you know you can't store 13 columns in 14 bytes. How does this happen? Here we go. These first 6 columns all together in this table repeat so often that Oracle has taken the entire 6-column chunk, moved it to the symbol table. How do I know this? Because after the 3-byte header down in the binary dump, I just see this one index value, 05. And when I dump the block, I can look at the symbol table and see in the 5th position these 6 columns. So altogether, this is about 19 bytes. I've replaced it with 1. That's good compression. And then these other columns, this one is 7 bytes, it's a date. This one is 7 bytes, it's another date. They too are so commonly seen that they're being replaced. Oh, that's great. 02 and 38. Let's see if this will work. No. Should work. Yeah, there we go. Okay, I'm going to go back. So isn't this pretty remarkable? I mean, they took 6 columns and replaced it with 1 byte. This column is replaced with 1 byte. This column is replaced with 1 byte. This column is null. No need to replace it. So you can see the FF right there. And then 1 byte, 1 byte, 1 byte. That's how you fit 13 columns into 14 bytes, including the 3-byte header. The data for 13 columns is actually in 11 bytes. Where did I end up going? There we go, okay. That's pretty cool. It gets even better than that. I've also noticed by dumping the symbol table that it's recursive. I've got entries in the symbol table that, like that 6-column entry, I think in some cases 4 of those columns are a separate entry themselves because they're repeated elsewhere. So Oracle has a very complex implementation of this very basic limp-ziv algorithm. So now, the question you might ask, how do I use compress basic? And how do I use compress for OLTP? How do they compare? It's pretty simple with compress basic. I'm just showing a block throughout its lifetime. In the beginning, it's empty. Here, I've loaded data into it using direct path loading. Direct path loading, again, loads a block all the way to the top. So the purple stuff is the compressed row data. The yellow stuff is the symbol table. It's full right up to the very top. This red thing is a header, block header. Now, once the data's been loaded, you can delete a few rows. And at some point, you can delete enough rows so that you clear away enough space so that the block goes back on the free list, or it's no longer free list, but we're now able to insert uncompressed rows into it. So here, you see at the very end, the block is full, but it's got compressed data mixed with uncompressed data. That can happen. The best of all situations, though, is when this happens. When this is the end of the life cycle. You load the data, you leave it alone. That's the best situation for use with compressed basic. That's your common data warehouse situation. You're going to load data into a fact table, never change it. But you can manipulate it, as shown here. For compress OLTP, it's different. Here, you start off with a block that's empty, and you do regular inserts, conventional inserts to load into it. Not direct path, but conventional. So I have lighter purple here. Now, here's this interesting thing. Have you seen, you've got in your kitchen, you've got a garbage compressor, right? Garbage compactor? Some of you do, I don't. But there's this thing called a garbage compactor. You keep putting garbage in it. When it gets full, you push a button, crushes everything down, then you can put more garbage in it until it's full, and you push a button, compresses everything down. This is a garbage compactor. Here's what happens. Data gets loaded up until the point of % free. This is the point where the block is considered full. Leaves 10% open space. That's default for Oracle. The last transaction to insert data into there that hits that hits full, essentially that transaction, that session, pushes the garbage compactor button. And now we end up with this. The data only takes up this much space. And then normal life comes along, and more rows get inserted. And more rows get inserted and updated, maybe deleted, until it hits full again. See, it's a mixture of compressed data and uncompressed data. But it reaches full, and that session becomes the one that pushes the garbage compressor button. And then it compresses. And so on until the block is full of compressed data. So it's a great mechanism. It works with just about anything. Again, Oracle does use it inside eBusiness Suite and PeopleSoft. That's a great, I think the term is you eat your own dog food. They're eating their own dog food on this stuff. It works very well. But this simple algorithm for compression really wasn't sophisticated enough. So at some point when Oracle was building Exadata, and they had bought Sun Microsystems, so they had ZFS. And also Larry decided to buy a new storage company called Pillar. They decided to do something special just for those storage platforms. And that is to take another old concept called columnar storage, as opposed to row-based storage. Oracle is row-based storage. I just described how a block is full of rows. Columnar storage is a database that stores its data in columns, and each item in the column is a row piece. It's an entirely different way of looking at things. But it's completely valid. And columnar storage works very, very well with compression. When you're using the same data type and possibly the same data values over and over again, being able to look at all those columns, 1,000 rows or 1,000,000 rows of the same column, allows you to apply more sophisticated compression algorithms. That's what HCC does. HCC stands for hybrid columnar compression. The reason for the word hybrid is this is columnar storage inside a row-oriented system. Hybrid. So rather than being a true columnar system where if you have a billion rows in a table, you're going to have a column with a billion rows worth of data, another column next to it with a billion rows, etc. What Oracle does is it breaks things up into chunks. Each column's worth of data holds 1,000 rows, or 2,000. I don't know actually how many. I haven't been able to use the block dump on the HCC segments, I'll show you. But it's got these great advantages. HCC is able to achieve compression ratios far beyond compressed basic and compressed OLTP. Like compressed basic and OLTP, you can expect to compress to 4 to 1, 5 to 1. I've seen as good as 6 and 7, maybe 8 to 1. It depends on your data, right? It depends on how repeated all the data values are. But this HCC, it varies, but you can see compression, especially for the archival quality compression, you can see compression ratios of 35 to 1, right? It takes a long time to compress data that small because they're using the algorithm, the bzip2 algorithm that goes over multiple times. But if this is data that isn't accessed very often, it's worth it to make it that small if you're only going to access it a couple times a year, right? Trade-off. So there are a lot of advantages and disadvantages. But the basic idea, the reason that columnar works well is that it helps with compression, and the select command and the select and update, those two commands, select in particular, is inherently column-based. You select columns. Your where clause has columns. Everything is columnar in a select statement. So columnar databases are used very much for, again, data warehouse, query-heavy type applications. Disadvantages of this is that, well, for a database that's row-based, this and insert and delete operations are row-oriented, it doesn't work very well if you're going to manipulate the data. So again, just like with anything else that you compress, the basic idea is that once you insert it and compress it, don't touch it. You can touch it, but it's not a great idea if you do. So here's what happens. With HCC, there's a new concept called a compression unit. Wow. Okay. Compression unit is essentially one row of data. That's how it's stored physically. But inside the compression unit, you've got, again, a header, this thing called a bitmap, and then you've got all the column values for about a certain number of rows, like 1,000. I just keep using that number 1,000. I don't know if it's valid. So for column 1, I've got all the rows for 1,000, all the column values for 1,000 rows. Same thing for column 2, column 3, column 4, column 5, so on, up to column 7. That's a compression unit. All told, that compression unit might physically make a row that is 100K long, far too big to fit in any database block. So that's where the concept of chaining comes in. So that compression, I go too far. Let's get it just right. So this big logical thing has to fit into physical 8K blocks. So Oracle has to break it up, kind of like that. Chain it. That's how it works. This is your hybrid part of columnar compression. And there's some good references, articles by Jonathan Lewis and Peter Brink. Brilliant articles explaining this. So you can do, one thing. Hybrid columnar compression, like compressed basic, is activated by direct path loads only. It's not like OLTP. Just like anything else, though, you can perform updates and deletes against something that was initially loaded as HCC compressed, but it's going to act a little bit weird. If you perform a delete, we're not actually going to delete the row data out of this compression unit. Instead, this bitmap header actually has a bit for every single row in the compression unit. Initially, it's 1. If the row gets deleted or updated, it gets set to 0, meaning don't pay attention to this row inside the compression unit. Instead, if it's deleted, it's deleted. But if it's updated, it gets inserted out into the table outside the compression unit as OLTP compressed. Complex stuff. Blah, blah, blah. Block dumps. I couldn't get block dumps. So here I just show relative compression ratios between the different kinds of compression. Again, two major kinds of compression, basic OLTP and HCC. Now, for our demantra, we wanted to apply one of these. I mean, God, it would be great if we could compress by 35 times. We could do full table scans till the cows come home, because we had terrific systems that had flash storage on it and everything. They would do very, very well against that. Oh, and I mentioned, I should have mentioned this too. There's a package called DBMS compression that will allow you to do what-if analysis. If you have a table that's not compressed, or if it's compressed another way, you can use DBMS compression to tell you what you can expect with that table's data, what you can expect in terms of a compression ratio. It's a very useful command to have. But anyway, and that's just the use of, that eye chart is just using the compression ratio. But okay, so with demantra, we couldn't use compress basic because the application code wasn't using direct path loads. Okay, we couldn't use compress for OLTP because the main table in the application had 770 columns in it. Remember the limit of 255? We couldn't use HCC because we weren't on Exadata. It was a 10G database. But even so, they could have upgraded to 11G and used Exadata, but they had already just bought great hardware. They weren't going to switch to Exadata. So what were we going to do? Now remember, way back, I mentioned that trailing low columns in the database block, when you have a row, let's say you have a table with 100 columns, but only the first 7 are populated, the other 93 take up no space at all. That's called trailing no columns. Trailing null values are not stored. So this demantra application had 770 columns in it. Only about 30 or 40 of those columns were being used. And what's even better is the customer had modified the table to add new columns. And when they added those columns, those were the columns being used. So 770 columns. I had the primary key in the very beginning of the row, 750 empty columns, and then at the end of the row, I had 20 or 30 used columns. Is there something I can do with that? The answer is absolutely yes. I created a procedure, I call it CARL, C-A-R-L, calculate average row length. The heart, and it's posted on the internet, the heart of CARL is reordering the columns according to the number of null values in the column. Those columns which are not null or have the most null values come first. Those columns which have nothing in them are placed last. So by doing that to the main table in the demantra application, we reduce the average row length from somewhere. There it is, 766 bytes to 102, just by reorganizing the table. I thought that was pretty cool. So if you have a situation with a data warehouse or any application that has a very wide table, lots of columns, and it's sparsely populated, only a few of those columns are used, maybe you can make use of this. The CARL procedure is out there for you to use if you like. I'm rather proud of the PL SQL that's in it too. I thought it was pretty cool. But it's rather like the DBMS compression package that I mentioned, where you can try it out to see if it will benefit you or not, without having to rebuild the table first to find out if it'll help you. So, whoops, Which type of compression should you use? It depends on your situation. I think probably by now with Oracle 12c and such, some of the limitations may have been lifted, but I don't think so. For compressed basic and OLTP, I think all the restrictions that I mentioned, they're still there. With HCC, Exadata is far more prevalent now. It's a lot easier to get your boss to buy Exadata, somewhat. Maybe that's a better solution than trying to reorganize the tables. But if you find yourself unable to use any one of those other solutions, maybe this will work. Maybe taking advantage of the way that Oracle already optimizes storage is a way to, do better. So, just additional stuff. Again, remember, I sometimes do this talk in 90 minutes. I know I'm already 5 or 10 minutes over, so I'm going to finish up here. But yeah, there's multiple ways to compress table data. Some of it is obvious, it's a supported feature. Other types of compression come about or are available because you have to know how Oracle stores data, which is the situation with the trailing no columns. So I hope this is interesting, and there's a list of different references on these topics that I've discussed. A lot of really great reading by really great writers and bloggers. And thank you for your attention. Thank you so much. If you have any questions, I'll be outside because, thank you. Four minutes over.